Right guys, welcome to this video on bearings and distances. Today we're going to be learning how to sketch bearings, represent them on paper. We're also going to learn how to interpret work problems and solve them using the sine and cosine rule. And our textbook of reference to help us with this will be the New General Mathematics for Senior Secondary Schools Book 2. And this textbook is referenced in our description using the Harvard referencing style. Alright, so before we get into the business of this video, we will need to remind ourselves of some of the elementary concepts on bearings and also some elementary concepts in geometry. Right, so once we do that, we'll get into the business of this video, which is interpreting work problems and using the sine and cosine rule, or the combination of both the sine and cosine rule, to solve these work problems or questions. Now let's move to the refresher course, where I will remind you guys, or just take you guys through a few things on the elementary and foundational concepts that we need to understand when it comes to bearings, and some geometry concepts that we need to understand as well. Now, bearing in the simplest term means direction. Bearing means direction. Now, we need to learn the 4 cardinal points, as this is the foundation of every single thing that we need to understand in bearings and distances. The 4 cardinal points are the north, the south, west, and east. So this is the north here, this is the east, this is the south, and this is the west. In between the north and east, we have the northeast, or simply NE. In between the south and east, we have the southeast, simply SE. In between the south and west, we have the south west, simply SW, and in between the north and west you have the north west, or simply NW. Now it is important to know that the angle between the north and the east, the north pole and the east, is 90 degrees. The east and south 90 degrees, south and west 90 degrees, and north and west 90 degrees. Okay, so there are 2 ways in which bearings can be represented, and the first one is acute angle bearing, and the second is 3-figure bearings. So you can either represent bearings in the acute angle notation or the 3-figure bearing notation. Right, so we're going to see what acute bearings are. We're going to learn what they mean and how we can represent them or sketch them. Now, by definition, acute angles are angles between 0 degrees and 90 degrees. That is, they are greater than 0 but less than 90 degrees. So what are acute angle bearings? Now let me show you some examples. In this diagram we have a picture of an acute angle bearing. Now it is called an acute angle bearing because it is between 0 and 90 degrees. As you see here, 56 degrees is between 0 and 90. So what you should know is that acute bearings are measured from the north or the south direction. Now we can see here that this is a bearing of B from A. Here. Now, how do we state this bearing? We can see that this is the north direction and this is the east direction. And we see that B is in the northeast direction. So to state this bearing, we simply say that the bearing of B from A is north 56 degrees east. Remember, what we're concerned with is the angle that rests on the North Pole, not this angle here. The angle that rests on the North Pole is what we're concerned with. That is why this bearing is stated as north 56 degrees east. As we can see, this 56 degrees rests on the north direction. So we see that the bearing of B from point A, this is point A here, the bearing of point B, that's this point, from this point, which is A, is north 56 degrees east. Now, I said our angle of concern is the angle that the line AB makes with the north direction. It's either the angle the line makes with the north direction or the south direction. It's not the angle it makes with the east direction or the west direction. What do I mean? Now remember I said that the angle between the north and the east direction is 90 degrees. So this angle here, the whole angle here from the north to this east direction is 90 degrees, right? And if this is 90 degrees, it means that this angle here from this point to this point will be 34 degrees. Now, you cannot say that the bearing of B from A is north 34 degrees east. This will be wrong. We're simply concerned with the angle that rests on the north direction. That's why we said the bearing is north 56 degrees east. Okay? So I just need to state this here just so that we won't get confused if we see any question where we have this angle stated and not this angle stated. In such cases, what we do is that we find the angle that rests on the north direction, or the angle of inclination between the line AB and the North Pole. Alright, so this is another example. I want to state the bearing that we see here. That is the bearing of X from Y. Now, remember, I said the angle that we're concerned with is the angle that rests on the north direction or the south direction. Now, the angle that rests on the north direction here is 70 degrees. So the bearing here would be north 70 degrees west, because it's in the northwest direction. So it's north 70 degrees west. Let's look at another example. Alright, so this is the third example. Now this bearing is south 40 degrees east. Okay, remember I said that we're concerned with the angle that rests on the North Pole or the South Pole. Now 40 degrees here rests on the South Pole, so the bearing here is south 40 degrees east. Now we'll see another example. Now we'll see here in this example that the angle XY makes with the West Pole is 18 degrees. Now remember, I said that what we'll be concerned with in acute angle bearings is the acute angle that the line that we're concerned with makes with either the North or the South poles. Now, we see that line XY makes an angle of 72 degrees with the North Pole. So we see here that the bearing here, the bearing of X from Y is north 72 degrees west. This is because it makes an angle of 72 degrees with the North Pole. Now remember, acute angle bearings must be between 0 degrees and 90 degrees. Alright, so now we've seen this example that the angle that MN makes with the west direction is 15 degrees. Now remember, what we're concerned with is the angle that it makes with the south. So we simply say 90 degrees minus 15 degrees. And that's equal to 75 degrees. So this angle here is 75 degrees. So we say that the bearing here, the bearing of N from M, is south 75 degrees west. Alright, so that's it for acute angle bearings. Alright, so we're going to be talking about the figure bearings now. And 3 figure bearings are 3 digits. 3 digits angles measured from the North Pole in a clockwise direction. For example, if I were to sketch a bearing of 246, a 3-figure bearing of 246 degrees, I would simply measure a 246 degree angle from the North Pole and represent that as my bearing. And I'm going to show you guys how to do that. Remember, I said that the angle between the north and the east here is 90 degrees. And this here, 90 degrees as well. This is 90 degrees. And this is 90 degrees. Meaning that from here to this point here, from the north to this point here, we go an angle of 90 degrees. From this point to this point here, we go an angle of 180 degrees. And from here all the way to this point here, we go an angle of 270 degrees. And from here all the way to this point here, we go an angle of 360 degrees. Okay? So if I were to sketch a bearing of 246 degrees, I'll simply move from the North Pole in the clockwise direction. Okay, so I can stop somewhere here. Okay, I can say that this is 246 degrees. Alright? So this is my bearing of 246 degrees. So this question here says that we should find the 3-figure bearing of B from A. All we just need to do is to find how much in degrees we need to turn from the North Pole to get to AB. Now, that will be this angle right here, this reflex angle right here. Now, we know that the sum of angles from this point back to the North Pole in this clockwise direction is 360 degrees. So if we have from here to this point here being 41 degrees, it means that this angle from here all the way to this point will be 360 degrees minus 41 degrees. And that would give us 319 degrees. Okay, now here we're required to sketch the following bearings. The first one is the bearing of B from A is 0, 40 degrees. So let's see how we can represent that. So the first thing I want to do is to draw your 4 cardinal points. So this is south, this is the west, and this is east. So a bearing of 0, 40 degrees, remember we're measuring from the north, so we can go from here to this point. Let's say we have 40 degrees here, it's this one here. So this is 40 degrees. So this is our bearing, the bearing of B from A. So A will be the reference point here, B from A here. So the bearing of B from A here in this diagram is 0, 40 degrees. Remember, we'll go from the north in the clockwise direction like this until we get to a 40-degree angle. So this is the bearing of B from A, from point A. All right. Now the second one, here we're required to sketch this bearing 45 south, 45 degrees west. It's going to be like this. Here will be 45 degrees, and it's the bearing of A from B. And the last one, so the last one is L is on a bearing of 200 degrees from K. So this point here will be K, and all we just need to do is to draw an angle from the north pole in the clockwise direction of 200 degrees. So let's say that this is the angle here, 200 degrees. So we'll say this is L, and this angle from here to here, that's 200 degrees. Okay, so now this question says that we should find the bearing of A from B, and the second part is to find the bearing of B from A. Now the bearing of A from B is simply 250 degrees, because you simply move by an angle of 250 degrees to get to this point. So what about the bearing of B from A? Alright. Now as a beginner, what you want to do here is to complete the diagram by drawing the other 3 cardinal points at A and B. Okay. So this is the south, this is the east, this is the west, this is east, this is the south, and this is the west. Okay, so how do I determine the, and remember this is point A here, and this point is B here. So how do I determine the bearing of B from A? That is this angle here, right? Now we don't know this angle here, so how can we find it? What we do know is that this angle from this point all the way to this point is 250 degrees. We also know that this angle here, from this point to this point here, is 180 degrees. Meaning that this angle from here to here will be will be 250 degrees minus 180 degrees. That gives 70 degrees. So we write 70 degrees here. That's this angle from here to here. Now remember from your elementary geometry, this angle 70 degrees is alternate to this angle. So it will be equal to this angle here. So that's 70 degrees. So now we know the angle from this north pole to this line AB. So we can easily say that the bearing of B from A is north 70 degrees east or 070 degrees east. So this is the acute angle bearing and this is the free figure bearing. Now what if we were asked to find the acute angle bearing of A from B? Now since we know that from this point measures an angle of 70 degrees, we can simply say that the acute angle bearing of A from B is south 70 degrees west. The acute angle bearing of A from B is south 70 degrees west. So it's simple like that. Now we're done with our refresher course on sketching bearings, and we also reminded ourselves of the concept of alternate angles from our elementary geometry. So now we'll move into the real business of the video, which is understanding how to interpret work problems and use the sine and cosine rule to solve them. Right now, we're going straight into the work problems involving bearings, where we'll learn how to use the sine rule and cosine rule to solve these problems. We'll learn how to apply them in solving or finding the solutions to those problems. But first of all, you know how in thriller movies, when there's a crime and a witness to that crime, sometimes police officers enlist the help of the witness to sort of give a graphic description of the perpetrators of the crime, right? And then they also get an artist to listen to the witness, and then with the description that the witness gives them, the artist is able to draw or sketch an image of the suspect. So that's pretty similar to what we're going to be doing here in solving work problems on bearings. So we're going to be using the description that the question gives us, and then with that description, we're going to be drawing sketches. So we'll make a sketch of a diagram from the description in the question, and then with that sketch, we'll be able to find the solution to the problem. So the sketch will make it easier for us. That's a graphical representation of the problem, which is the sketch, will make it easier for us to solve the problem using the sine rule or the cosine rule. So I'm going to walk you guys through all the steps and the thought process that goes into solving each question. Each question has its peculiarity, has its own uniqueness, right? So we're going to look at each question, and then we're going to see all the thought processes that go into sketching them. And I'll show you guys in a step-by-step manner. And as we go on, you guys will learn how to sketch and then solve problems after sketching. Right, so let's begin with exercise 5C, which is mostly sine rule. And then after exercise 5C, we'll go to the exercise 9A, which is the cosine rule. So let's begin. Now, the first question in this exercise says, a point X is 34 meters due east of a point Y. The bearings of a flagpole from X and Y are north 18 degrees west and north 40 degrees east respectively. Calculate the distance of the flagpole from Y. Okay, let's move over to our Microsoft whiteboard to see how we can sketch this problem and solve it. Okay, so the first part of the question says that a point X is 34 meters due east of a point Y. So say you have the point Y here. What you want to do is to draw your 4 cardinal points first. So you have the north, south, west, east. And remember, this is a point y. So we're told that x is east of y. So, and 34 meters east of y. So you have x to be here at this point. This will be 34 meters. Have point x. We have the north pole here of x. Let's call it N1. We have south of x, and then we have, this is east of x here. And of course, this point here is west of x. So we'll call this W1, S1, and 1. Okay, this is point x, remember. And we're told that the bearings of a flagpole from x and y are north 18 degrees west and north 40 degrees east, respectively. So let's take from x first, which we're told is the bearing of the flagpole is north 18 degrees west from x. So we can say that this here is 18 degrees. So I'll say this is 18 degrees here, from here to here. And then the bearing of the flagpole from y, we're told, is north 40 degrees east. So we can say from this point to this point here, let's say this is 40 degrees. And let's say they all meet at this point here, where the flagpole will be. We can call it F. Okay. So we can call this point F. This is where the flagpole is. And we're told to calculate the distance of the flagpole from y. That is Fy. Okay, so that's how you sketch the information presented in a word problem. You take it bit by bit and then put all the information that you have in the diagram. Okay, so now that we have sketched the problem, I'm just going to draw a neater version of this sketch so that we'll begin solving. Okay, so this is a neater version of what I sketched earlier. This is the diagram. This is a sketch for question 1. So now remember, we're to find Fy, right? Find Fy. That's the distance of the flagpole from y. So we just complete some of the angles in the triangle. So we know that here will be 90 minus 40 degrees. That will be 50 degrees. Here will be 90 minus 18 degrees. That's 72 degrees. And here will be 180 degrees minus the sum of 50 and 72 degrees. So we'll have it as 58 degrees. Also remember that we're told that the distance between y and x is 34 meters. So we have this as 34 meters here. So now let's see how we can use the sine rule to find Fy. Okay, so the question is calculate the distance of the flagpole from y. That is, find Fy. Okay, so we said that angle F, of course, is equal to 180 degrees minus 50 degrees plus 72 degrees. And that gave us 58 degrees. And the reason is sum of angles in triangle FYX. Now we can use the sine rule to find Fy. Using the sine rule to find Fy. So from the sine rule, we know that xy over sine f. Okay, so the sine rule basically is that the ratios of sides of a triangle and their opposite and the sine of their opposite angles are equal. Now we see that xy is directly opposite this angle f. So it means that xy over sine f will be equal to fy over sine 72 would also be equal to fx over sine 50. That's what the sine rule is simply. So we have it here that xy over sine f equals fy, which we have to find, over sine x. Okay? Because fy is opposite x. Fy here is opposite x, angle x. Okay? So this is the sine rule. Now let's state the values that we have. We know that xy equals 34 meters. We know that f equals 58 degrees. We know that fy, okay, we don't know that. We know that angle x is 72 degrees. So we can put all these values that we know to find the unknown. We can put them in the equation to find the unknown, which is fy. So putting in those values, we have that 34 over sine f, which is 58 degrees, equals fy over sine 72 degrees. So if we cross multiply, we have that 34 times sine 72 degrees equals fy times sine 58 degrees. We have fy equals 34 times sine 72 degrees over sine 58 degrees. That is dividing both sides by sine 58 degrees. So isolate fy. Okay. So we have that fy equals 34 times sine 72, which is 0.9511, divided by sine 58, which is 0.8480. And this is equal to, once you use your calculator to evaluate this, you get 38.133 meters. And I'm going to put this correct to three significant figures as 38.1. So three significant figures. So this is the answer. The distance of the flagpole from Y is 38.1 meters. Okay, can I write meters here? Yeah. Right, so that's question one. Let's move to the second question, which is question two. Okay, so question two says, a man walks due west for 4 kilometers. He then changes direction and walks on a bearing of 197 degrees until he is southwest of his starting point. How far is he then from his starting point? Okay, let's move over to Microsoft Whiteboard to see how we can sketch the information presented in this question. Okay, so this is question two. And it says, A man walks due west for 4 kilometers. Now let's say the man's starting point is here. I'm going to call it S. And as usual, I'm going to draw my 4 cardinal points. So I have north, south, east, and west, of course. So it's W. Okay, so we're told that the man walks 4 kilometers due west. That's 4 kilometers in the west direction. Okay, so it's 4 kilometers. Okay, so he walks to this point and then changes direction and walks on a bearing of 197 degrees. So I'm going to draw my 4 cardinal points at this point. Yeah. I'm going to call this N1. I'm going to call this S1. I'm going to call this W1. And of course, this is the east of this point. So let me just call this point here T, point T. And we're told that it changes direction and walks on a bearing of 197 degrees. Now, a bearing of 197 degrees will go like this from the north in the clockwise direction to, let's say, this point here. So let's say that this angle here is 197 degrees. Goes to this point here. So remember, if this is 197 degrees and from here to this point is 180 degrees, so this point to this point here is 17 degrees. All right, so clearly 17 degrees. Okay, so he walks to this point until he is southwest of his starting point, meaning that until he is 45 degrees west of his starting point. Well, this is a bit confusing. So instead of calling this S, I think I should call it X, just so there is no confusion between this point S and the south here. So I'm going to call this X instead of S. So let's call this X, and let's call this Y. Okay, so this is X here. And remember, he walks until he is southwest of his starting point. So let's say that should be here. Here, right? 45 degrees. Yep. So this is X, Y, Z. Let's call this points, this final point Z. You can also draw 4 cardinal points here. A point Z. Call this N2. Call this S2. And call this W2 as the east direction, and call this E2. So if here is 17 degrees, here will be 17 degrees. And if here is 45 degrees, here will be 45 degrees as well, because 90 minus 45 is 45. So it means that here will be 45 degrees as well, because this angle is alternate to this angle. So it means that the whole of this angle here, from this point to this point, will be 45 degrees. So this small angle inside here will be 45 minus 17 degrees, and that is 28 degrees. So this angle here is 28 degrees. Okay, so yeah, we have one more. If here is 17 degrees from here to here, 17, it means that this whole angle from here to here will be 90 plus 17 because this angle here is a right angle. So this whole angle will be 90 plus 17 degrees. That's 107 degrees. Okay, so now we have all the angles of the triangle complete. So I'm still going to explain this with a neater diagram. So let's quickly do that so that it's clearer to you guys. Okay, so this is question 2, and this is a neater sketch of the problem. So remember, we identify this point as X, and we're told that man walked 4 kilometers from due west from the starting point. So this is 4 kilometers to a point Y, and then he changes direction in a bearing of 197 degrees until he is southwest from his starting point X. So this is from the north, of course, to this point here. This is 197 degrees. So this angle here will be 17 degrees. That's from here to here. And then, of course, this is a right angle. So this whole angle here will be 107 degrees. That's 90 plus 17 degrees. Okay. And then let's call this point Z. And remember, as I said, the question says that he walks to this point until he is southwest of X. Now, southwest of X means that until he is on a bearing of south 45 degrees west from X. That means here will be 45 degrees. If here is 45 degrees, here will be 45 degrees as well. That's 90 minus 45 degrees here. And if here is 45 degrees, here will be 45 degrees because this angle is alternate to this angle. Okay. And then you can see that this 17-degree angle here is also alternate to this one here. So say this is 17 degrees as well. That's from here to here. And then we know that from here to here is 45 degrees. So it means that 45 degrees minus 17 degrees will give us this small angle here. And that will be 28 degrees, right? Okay, so let me just make it neater. So this whole angle here is 45 degrees. So this small angle here will be 28 degrees. So we have that the angles of the triangle are 107 degrees, 45 degrees, and 28 degrees, respectively. That's angle Y, angle X, and angle Z. Now we are to find the distance from his final point to his starting point. The final point is Z here. Let's find the distance of Z from X, that is XZ. So we're to find XZ. So let's see how we can do this. Now we can use the sine rule to find XZ. Okay, so remember, The sine rule is simply the ratio of the size of the triangle and the sine of their opposite angles are equal. So we have that xz over sine 107 degrees is equal to xy over sine 28 degrees. Now we're using xy because we know xy to be 4 kilometers. So we're working with what we know. We're using what we know to find what we do not know. So xz is what we were to find. We don't know that. We know xy to be 4 kilometers, right? So we're going to put 4 kilometers into this equation. So we have that xz over sine 107 degrees equals 4 over sine 28 degrees. Now cross multiplying, we have that xz times sine 28 degrees equals 4 times sine 107 degrees. Dividing both sides by sine 28 degrees to isolate xz, we have that 4 times sine 107 degrees. We have that xz equals 4 times sine 107 degrees over sine 28 degrees. Now we have that xz equals 4 times sine 107 degrees, which is 0.9563 over sine 28 degrees, which is 0.4695. So xz equals 3.8252 over 0.4695. And this is equal to 8.147 kilometers. Now I'm going to write this to correct to 3 significant figures. So xz is 8.15 kilometers to 3 significant figures. So this is the solution. So we'll say that the distance of the man from his starting point is 8.15 kilometers. So this is the answer. Now let's move to the third question. Okay, so question 3 says, a girl starts from question 3 says, a girl starts from a point A and walks 285 meters to B on a bearing of 078 degrees. She then walks due south to a point C, which is 307 meters from A. What is the bearing of A from C, and what is BC? Okay, let's sketch this first and then find the solution to the problem. So this is question 3. And we're told that a girl starts from point A and walks 285 meters on a bearing of 078 degrees to a point B. So let's say she starts from this point here point A. So we'll draw our 4 cardinal points. It's point A here. So this is north, of course, south, this is east, and west. So she walks 285 meters on a bearing of 078 degrees to a point B. Okay, so let's say this is 78 degrees here. And then she walks from point A, 285 meters, to a point B. So let's call this point here E. She then walks due south to point C, which is 307 meters from A. Okay, so we're told that from point B, let's call this N1, that's north of B, call this S1, south of B, we can call this E1, which is east of B, and we can call this W1, which is west of B. So we're told that she walks due south of B to point C. So let's say this is point C here. And we're told that this point C is 307 meters from A. Alright, so let's say this is 307 meters, right? So we're to calculate the bearing of A from C and find BC. Okay, first we're going to have to draw the our 4 cardinal points here. Let's call this N2. Let's call this S2. And call this E2. And call this W2. Okay, so the bearing of A from C, remember we'll go from the north direction in the clockwise direction. So the bearing of A from C, remember we'll go from the north of C in the clockwise direction like this until we get to point C. Now this angle from here to this point here on line AC is the bearing of A from C. So let us complete some aspects of the triangle that we can complete from the diagram. So we know that this is 78 degrees here, and it's alternate to this angle here. So this is 78 degrees as well. So with this information, we have 78 degrees opposite line AC, which is a known side. So we can use the ratio of line AC and the sine of its opposite angle to find angle C here, right? So we just equate it to the ratio of 285 and the sine of C, and then we find angle C. And of course, 360 degrees minus angle C will give the bearing of A from C. All right. Okay, so let's do this on a meter sketch and then find the solutions to the problems. So this is question 3 here. And so we're told that the girl starts from point A. So we're going to say this is point A here. And then she walks 285 meters to point B. Alright, so this is 285 meters on a bearing of 078 degrees. So this is 78 degrees here. This is bearing of 078 degrees, right? Remember, we go from the North Pole in a clockwise direction. That's how we measure the angle. So this is point B. This is north of B, south of B, east of B, and west of B. So we're told that she then walks due south from point B to a point C, which is 307 meters from A. So from point B, she walks due south to a point C, which is 307 meters from A. That's this distance here. So we're to find the bearing of A from C. So we can call this N2, that's north of C. This is S2, south of C, E2, and W2, which is east and west of C respectively. So we're told, so we've been asked to find the bearing of A from C. So we have to go from the north of C in a clockwise direction. We measure that angle in a clockwise direction until we get to line AC, like this. So this reflex angle N2 CA will be the bearing of A from C. Alright, so let's see how we can find that. But first of all, we can complete some information that we have here. We see that this angle 78 degrees is alternate to this angle here. So we see that this is 78 degrees as well. Right, so now we have one known angle and we have its opposite side known. That's one known angle of the triangle, and we have the side opposite that angle known. And then we need to find angle C, because angle N2CA, reflex angle N2CA, is 360 degrees minus angle C. Alright, so we can use the sine rule because we know the length of the side opposite angle C. So we're to find the bearing of A from C, and that is equal to reflex N2CA, reflex angle N2CA. And reflex angle N2CA is equal to 360 degrees minus angle C. So how do we find angle C? Okay, so we use the sine rule. We use the sine rule to find angle C. So we say that AC over sine B equals AB over sine C. AC over sine B equals AB over sine C. So AC is 307 meters over sine B, which is 78 degrees, and AB is 285 over sine C. So if we cross multiply, we have that 307 times sine C equals 285 times sine 78 degrees. And then if we divide both sides by 307 to isolate sine C, we have that sine C equals 285 times sine 78 degrees divided by 307. So sine C equals 285 times sine 78 degrees, which is 0.978 over 307. So sine C equals 278.759 over 307. So sine C equals 0.9080. So C equals the arc sine of 0.9080. So we have that angle C equals 65.23 degrees. Now we find the bearing of A from C. Now remember, as we stated earlier, the bearing of A from C is equal to reflex angle N2CA, which is equal to 360 degrees minus angle C. Alright, so we know that angle C from our calculation is 65.23 degrees. Therefore, the bearing of A from C will be 360 degrees minus 65.23 degrees, and that is 3. Okay, so we're told that a girl starts from point A and walks 285 meters on a bearing of 0.78 degrees to a point B. So let's say this is 78 degrees. So it starts from point A and moves to. So we're told that a girl starts from point A and walks 285 meters to B on a bearing of 0.78 degrees. So let's say this is 78 degrees here, and she walks 285 meters to B, right? So let's say this is north of B, this is south of B, east of B, and west of B. And then from B, she walks due south to point C, 307 meters from A. So this is south of B to point C here, 307 meters. Sorry. So this is south of B, and she walks to point C here, and we're told that C is 307 meters from A. Right? We're to calculate the bearing of A from C. So let's say this is N2, which is north of C. This is E2, S2, and W2. So the bearing of A from C will be the angle starting from the north direction of C in the clockwise direction until we get to line AC. So the bearing of A from C will be reflex angle N2CA. Alright, so let's complete some of the information that we can on the triangle. So we see that this angle here is 78 degrees. It means that this angle here will also be 78 degrees because they are alternate angles, and alternate angles are equal. Okay, so now we have one known angle, and the side opposite that known angle is also known, and then we have one side known, another side, and then we have another side known, and it is opposite this angle here. Now we know that the bearing of A from C is reflex angle N2CA, and this reflex angle N2CA can be gotten from 360 degrees minus angle C of the triangle. So we need to find this angle C of the triangle here, and the sine rule will help us find angle C. So let's see how we can use the sine rule to find angle C, and then find the bearing of A from C. Alright, so the bearing of A from C is reflex angle N2CA, which is equal to 360 degrees minus angle C. Right, so how do we find angle C? So we use the sine rule to find angle C. Now, say that AB over sine C equals AC over sine B. So we know that AB is 285 meters. So 285 meters over sine C equals 307. That's AC over sine 78 degrees. That's angle B. So when we cross multiply, we have that 285 times sine 78 degrees equals 307 times sine C. We divide both sides by 307 to isolate sine C. We have that sine C equals 285 times sine 78 degrees over 307. So sine C equals 285 times sine 78 degrees, which is 0.97881 over 307. So sine C equals 278.759 over 307. So sine C equals 0.9080. So C equals arc sine 0.9080. So angle C equals 65.23 degrees. Alright, so now we know angle C, and we can easily find the bearing of A from C. So remember, the bearing of A from C reflects angle N2CA, which is equal to 360 degrees minus angle C. Alright, and that is equal to 360 degrees minus 65.23 degrees, and that is equal to 294.77 degrees. So I'm going to approximate this to one decimal place, so that's 294.8 degrees to one decimal place. So the bearing of A from C is 294.8 degrees. Alright, so now we know the bearing of A from C to be 294.8 degrees. So what we do next is to find BC. That's the second part of the question. Alright, find BC. So remember, we calculated angle C to be 65.23 degrees. So we can find angle A here, which is opposite the length of the side of the triangle that we're supposed to find. We can find this by taking the sum of 78 degrees and 65.23 degrees away from 180 degrees, because the sum of angles in a triangle is 180 degrees. Alright, so let's find angle A first. So angle A equals 180 degrees minus 78 degrees plus 65.23 degrees. Let's write this clearly. Yeah. So angle A equals 36.77 degrees. Alright, so now we can find length BC using the sine rule. So we use the sine rule to find BC. So BC over sine A equals AC over sine B. So BC over sine A, which is 36.77 degrees, equals AC, which is 307 meters, over sine B, which is 78 degrees. So we cross multiply. We have BC times sine 78 degrees equals 307 times sine 36.77 degrees. So BC equals 307 times sine 36.77 degrees over sine 78 degrees. So BC equals 307 times sine 36.77 degrees, which is 0.5986, divided by sine 78 degrees, which is 0.9781. All right. So BC equals 187.88. Let's write this clearly. Is 8.5, and it's in meters, of course. So I'm going to approximate this to three significant figures. So it is 188 meters to three significant figures. Right, so those are the solutions to the questions. Question 4 says, the bearing of a house from a point A is 319 degrees. From a point B, 317 meters due east of A, the bearing of the house is 288 degrees. How far is the house from A? So let's sketch this and then solve. So this is question 4. And it says the bearing of the house from the point A is 319 degrees. All right, so let's say this is our point A here. So we draw 4 cardinal points here. So this is north, this is south of A, this is east of A, and west of A. So we're told that the bearing of the house from the point A is 319 degrees. All right, so 319 degrees from the North Pole, like this. So let's say somewhere here. Okay, so this is the point here where we have the house. And we're told that from a point B, 317 meters due east of A, the bearing of the house is 288 degrees. All right, so from point B, which is 317 meters due east of A, so let's say this is point B here, 317 meters due east of A. We have point B, So we can call this N2, which is north of B. We call this S2, which is south of B. And call this E2, which is east of B. And of course, this is W2, which is west of B. So we're told that the bearing of the house from B is 288 degrees. So it goes from the north pole in a clockwise direction all the way here, right? Just slightly above the west pole, right? So that's 288 degrees. Of course, remember this angle here is 319 degrees, right? So this is the bearing of the house from B. So let's just connect this, yeah. All right, so we can call the house point C here. Okay, so now we're to find how far the house is from A. That's AC from here to this point here. Okay, so let's complete some of the information that we have here. So remember, this is a 90-degree angle here, and this angle here will be 360 degrees minus 319 degrees. This angle here, 360 degrees minus 319 degrees, and that is 41 degrees. So this angle here is 41 degrees. So it means that the whole of this angle here will be 90 degrees plus 41 degrees, and that is 131 degrees. So this whole angle from this point to this point is 131 degrees. So what about this small angle here? Now this small angle here will be 288 degrees minus 270 degrees, and that is 18 degrees. So we have an 18-degree angle here. Okay, so it means that we can now find this angle, which is opposite this known side, which is AB. And how do we find it? This angle will be 180 degrees minus the sum of 131 degrees and 18 degrees, and that is 31 degrees. Now let's represent all of this in a meter sketch and find AC. Okay, so this is question 4. Alright, so we said that this is our point A here, and the bearing of our house is 319 degrees from A. So we went from the north of A in the clockwise direction, measured our 319-degree angle, right? So we got to this point here, all right, and then we were told that B is due east of A at a distance of 317 meters. So this is B here. And we're told that the house is on a bearing of 288 degrees from B. So it goes like this in a clockwise direction here. So this is 288 degrees. All right, so we have our house here. So we can call this C. This is where the house is at point C. So to find this angle, we simply subtracted 319 from 360 degrees. 360 degrees minus 319 degrees. That's 41 degrees. And remember, this is a right angle, that's 90 degrees. This is 41 degrees, 90 degrees. It means that this whole angle here is 90 plus 90 degrees plus 41 degrees, and that is 131 degrees. So this is 131 degrees here. All right, and this angle here will be 288 degrees minus 270 degrees, right? And that is 18 degrees. So we have this angle to be 18 degrees. And then this angle here is 180 degrees minus the sum of 131 degrees and 18 degrees. And we've got that to be 31 degrees. So this angle here is 31 degrees. So now we've gotten all the information that we need to solve for AC. All right, so let's find AC. So we're to find the distance of the house from A. And the distance of the house from A is equal to AC. So we use the sine rule to find AC. All right, so using the sine rule, we have that AC over sine B equals the known side, which is AB, over its opposite angle, which is sine, over the sine of its opposite angle, I beg your pardon, which is sine C. So AC over sine B, which is 18 degrees, equals AB, which is 317 over sine 31 degrees. So when we cross multiply, we have that AC times sine 31 degrees equals 317 times sine 18 degrees. So when we divide both sides by sine 31 degrees, we have that AC equals 317 times sine 18 degrees over sine 31 degrees. So we have that AC equals 317 times sine 18 degrees. That's 0.3090. That's sine 18 degrees over sine 31 degrees, which is 0.515. Alright, so AC equals 97.953 over 0.515. So AC equals 190.2 meters. So I'm going to approximate this to three significant figures, and that is 190 meters. So three significant figures. Right, so the distance of the house from A is 190 meters. Okay, next question says, the bearings of ships A and B from a port P are 225 degrees and 116 degrees respectively. Ship A is 3.9 kilometers from ship B on a bearing of 258 degrees. Calculate the distance of ship A from P. Now we're told that the bearings of ships A and B from the port P at 225 degrees and 116 degrees respectively. Right, so let's say we have our port P here. So as usual, we draw our 4 cardinal points. So south, so it's west, and east. So we're told that the bearings of ships A and B from P are 225 and 116 degrees respectively. So this is our point P here. The bearing of A from P is 225 degrees. So let's start with A first. So this is our point P here. So let's start with the bearing of A from P, which we're told is 225 degrees. So remember, we go in a clockwise direction from the North Pole to an angle of 225 degrees. So we go like this to somewhere here. That's 225 degrees. So we say this is point A. And then for B, that's 116 degrees. We go again from the north to this, let's say somewhere here. And that's this one, that's 116 degrees. So this is our point B. So we're told that ship A is 3.9 kilometers from ship B on a bearing of 258 degrees, meaning that ship A is on a bearing of 258 degrees from B. So we have B here. So this is north of B for the N1. This is south of B for the S1, and then east of B, and of course west of B for the W1. So we're told that point A is on a bearing of 258 degrees from B. So we go here like this until we get to 258 degrees, which should be somewhere here. Right, so it means that we will have to make this line longer so that it meets this point here, which is a bearing of 258 degrees from B. So this is 258 degrees. So we just make this line longer. Okay, so we draw this. Yep. So it's here at this point. Alright, so this is point A. Alright, so we have drawn the sketch. Now let's fill up the angles. So first of all, remember that this angle from here to this point is 116 degrees. And remember that this is 90 degrees. So it means that this small angle from here to here will be 116 degrees minus 90 degrees. And that equals 26 degrees. So this angle here is 26 degrees. And we can see that it is alternate to this angle here. So this will be 26 degrees as well. Now, what about this small angle here between the west pole and line AB? How do we find that? Now, from this north pole to the west pole is 270 degrees. So it means that this angle from this point to this point between the west pole and AB will be, this angle here will be 270 degrees minus 258 degrees. And that is equal to 12 degrees. So this small angle here is 12 degrees. 12 degrees. So it means that this angle B here, that is between line AP and line AB, will be 26 degrees. 26 degrees plus 12 degrees. And that is equal to 38 degrees. So this angle here is 38 degrees. Okay, so now we have one angle of our triangle to be 38 degrees. So what about this angle here? Okay, so we have this to be 26 degrees. It means that this angle here will be okay, so we have this to be 26 degrees. So it means that this angle here will be 90 minus 26 degrees. And that gives us that gives us 64 degrees. So what about this angle from here to here? Now remember, from the North Pole to line AP, the angle there is 225 degrees. So it means that this angle here will be 270 degrees minus 225 degrees. And that's 45 degrees. So if this is 45 degrees, it means that this angle here will be 90 minus 45 degrees. That gives us 45 degrees as well. So it means that this whole angle P, that's the angle that line AP makes with line BP, is 45 degrees plus 64 degrees. And that's 109 degrees. Okay, and then we're told that the distance of A from B is 3.9 kilometers. So now we have all the information that we need to help us find the distance of A from P. So let's get a neater sketch of this and then use the information that we have to solve for AP. Alright, so we have our port P here, north. This is north of P. And we have the first shape A, which is an bearing of 225 degrees. That's like this. So we have A here. And the second shape, which is an bearing of 116 degrees, like this. So it's B, so we have B here. And then we're told that A from B, the distance of A from B is 3.9 kilometers. And it's on a bearing of 200, and A is on a bearing of 258 degrees from B. So we have 258 degrees here. Alright, and if this is 258 degrees, it means that the small angle here will be 270 degrees minus 258 degrees. And that's 12 degrees. Right, so what about this angle here? Remember, this is 90 degrees. And since this angle from here to this point is 116, it means that this angle here, the small angle here, will be 116 minus 90 degrees, and that is 26 degrees. So this 26-degree angle here is alternate to this angle here. So this will be 26 degrees as well. So this whole angle here will be 26 plus 12 degrees, and that's 38 degrees. Now, if this is 26 degrees from here to here, this angle here will be 64 degrees. So what about this angle from here to here? Now remember, this from the North Pole to line AP is 225 degrees. So it means that this angle will be 270 degrees minus 225 degrees, and that's 45 degrees. So if this is 45 degrees, it means that this angle from here to here will be 45 degrees. That's 90 minus 45 degrees. So the whole of this angle here will be the sum of 45 degrees and 64 degrees. That's 109 degrees. All right, so now we have two angles, 109 degrees and 38 degrees. And this is sufficient. And then we also have a distance of 3.9 kilometers. So this is sufficient information for us to find the distance of A from P. That's the distance of ship A here from P. So let's get right into the calculation. So we're to find AP. Right. Now AP over sine B equals AB over sine P. So we have line AB to be 3.9 kilometers. We have angle P to be 109 degrees. We have angle B to be 38 degrees. So how do we find AP? We simply put in values in this equation and then solve for AP. So AP over sine B, which is 38 degrees, equals AB, which is 3.9 over sine 109 degrees. So if we cross multiply, we have that AP times sine 109 degrees equals 3.9 times sine 38 degrees. Dividing both sides by sine 109 degrees to isolate AP, we have that AP equals 3.9 times sine 38 degrees over sine 109 degrees. So we have that AP equals 3.9 times 0.6157, which is sine 38 degrees, over sine 109 degrees, which is 0.9455. So AP equals 2.4012 over 0.9455. So AP equals 2.539 kilometers. And then, of course, so three significant figures, AP equals 2.54 kilometers. Therefore, distance of ship A from P equals 2.54 kilometers. Okay, so question 6 says, an airplane flies from a town X on a bearing of north 45 degrees east to another town Y. a distance of 200 kilometers. It then changes course and flies to another town, Z, on a bearing of south 60 degrees east. If Z is directly east of X, calculate to three significant figures: the distance from X to Z and the distance from Y to XZ. Okay, let's move to our whiteboard and sketch this question. This is question 6, and we're told that an aeroplane flies from town X. So this is X here. We have our 4 cardinal points. That's from the north here. Okay, so we're told that it flies from town X on a bearing of north 45 degrees east to another town Y. So this is north 45 degrees east to a town Y. A distance of 200 kilometers. Okay, so control our 4 cardinal points at Y. We call this N1. Okay. From town Y, and then we're told that from town Y it changes course and flies in a bearing of south 60 degrees east to Z. Okay, so this is Y, and a bearing of south 60 degrees east will be here. This angle here, which is 60 degrees. So a town Z, which is directly east of X. Okay. Yeah. So this will be Z east of X and on a bearing of south 60 degrees east from Y. Okay, so this is the sketch of the diagram. So we're to find the distance from X to Z, and we're to find the distance from Y to XZ. Okay, that should be the perpendicular distance. So this will be it here. Distance from Y to XZ. That should be the perpendicular distance. All right. So let's just call this point O. So let's find OY. Right, so let's move to a neater sketch of this question and then do the calculations. All right, so this is question 6, and we have our neater sketch here. Remember, the plane starts from point X, flies on a bearing of north 45 degrees east to Y. Remember, this is north, this is N1, and then from Y, it flies, okay, and of course the distance between X and Y is 200 kilometers. And then from Y, it flies to Z on a bearing of 50 degrees on south 60 degrees east. Sorry. So this is 60 degrees here. Until it is directly east of X. So this point here, directly east of X. So this is where Z will be. So this is our point Z here. Alright, so we're to find XZ, distance of X from Z, and we're also to find the distance of Y from XZ, that's this point to XZ. Right, so we're going to assume that it's the perpendicular distance that we've been asked to find, because that's what we can find given the information that we have here. So I'm just going to draw a line, a broken line to join points Y with XZ. Okay, so this is a broken line joining points Y and XZ. So I'm just going to call this point O here. Right, and it's a perpendicular distance. Okay, so let's begin the calculations. we're going to start by completing the angles that we have here. Okay, so this is 60 degrees here. And remember, if this is 45 degrees, this will be 45 degrees as well, because 90 minus 45 is 45 degrees. So what about this angle here? Now, if this is 45 degrees, if this angle here from here to here is 45 degrees, this will also be 45 degrees because they are alternate angles. So this whole angle here will be 45 degrees plus 60 degrees, and that's 105 degrees. Okay, so we need to find this angle here. So this angle here will be 180 degrees minus the sum of 105 degrees and 45 degrees, and that is 30 degrees. So this angle here is 30 degrees. Right, so now we have all these angles, we have all the information that we can use to find xz and find the distance OY. So let's begin the calculations. Find xz. So using the sine rule, xz over sine y equals xy over sine z. So we know that xy equals 200 kilometers. We know that y equals 105 degrees. We know that z equals 30 degrees. So how do we find xz? So xz over sine 105 degrees equals 200 over sine 30 degrees. Alright, so if we cross multiply, we have that xz times sine 30 degrees equals 200 times sine 105 degrees. So if we divide both sides by sine 30 to isolate xz, we have that xz will be equal to 200 times sine 105 degrees over sine 30 degrees. So xz will be equal to 200 times sine 105, which is 0.9659 over sine 30, which is 0.5. That's a special angle. So xz equals 193.18 divided by 0.5. So xz equals 386.36 kilometers. So three significant figures, xz is 386 kilometers. Right, so now we found xz. Let's find the distance from y to line xz. Now for the second part of the question was to find the distance from y to xz. So here we're taking the perpendicular distance from y to xz. Alright, and then we have shown it in our diagram to be line OY. So we see from the diagram that sine x is equal to OY over line XY, which is equal to the opposite over the hypotenuse. So sine (45°), which is X, so sine 45° equals OY, which is the opposite, over XY, which is 200 kilometers. So OY equals 200 kilometers times sine 45°, and that's 200 kilometers times 0.7071, and that's 141.42 kilometers. So OY, so three significant figures, is 141 kilometers. So the distance from Y to XZ is 141 kilometers. Okay, so that's it for question 6. Question 7 says, a mast hangs from a horizontal beam by two strings as shown in figure 5.16. Use the data in figure 5.16 to calculate the length of the longer string. So this is the longer string here, and we're to calculate its length. Okay, so let's move to our whiteboard to do this. So this is question 7, and we're just going to label this as A, B, and C. So as to find the length of the longer string, which is AB, from the diagram. So we're to find AB. Alright, so we can easily use the sine rule since we know one side of the triangle to be 2.6, and we know its opposite angle to be 38 degrees. And then we know the opposite angle of the unknown side to be 74 degrees. So we can easily find the length of AB. That's the longer string. So we use the sine rule to find AB. Alright, so AB over sine C equals AC over sine B. Now we'll put in the values. That's the known values. AB over sine 74 degrees equals AC, which is 2.6 meters, over sine 38 degrees. So when we cross multiply, we have that 2.6 times sine 74 degrees equals AB times sine 38 degrees. So divide both sides by sine 38 degrees to isolate AB. So we have that AB equals 2.6 times sine 74 degrees over sine 38 degrees. So we have that AB equals 2.6 times sine 74 degrees, and sine 74 degrees is 0.9613 over sine 38 degrees, which is 0.6157. So AB is equal to 2.6 times 0.9613. That is 2.4994 over 0.6157. So AB equals 4.059 meters. Right, so I'm going to approximate this to three significant figures, and this is 4.06 meters. So three significant figures. So we say that the length of the longer string is 4.06 meters. Question 8 says, an aircraft is timetabled to travel from A to B. Due to bad weather, it flies from A to C, then from C to B, where AC and CB make angles 27 degrees and 66 degrees with AB. If AC equals 220 kilometers, calculate AB. Alright, so we're told that the aircraft flies from, due to bad weather, the aircraft flies from A to C, and then from C to B. We're told that AC makes an angle of 27 degrees with AB, and that BC makes an angle of 66 degrees with AB. Alright, so we're to calculate the length of AB. We're also told that AC is 220 kilometers. We're to find AB. Alright. Now we need to know the angle that is directly opposite AB. That's this angle here, angle C. And that is given by 180 degrees minus the sum of 27 degrees and 66 degrees. So let's write all of that down. And then after we find angle C, we'll use the sine rule to solve for AB. So angle C equals 180 degrees minus the sum of 27 degrees and 66 degrees. And this is equal to 87 degrees. So using the sine rule, to find AB, we have that AB over sine C equals AC over sine B. Now we're going to put in all the values, all the known values. AB over sine C, which is 87 degrees, equals AC, which is 220 kilometers, over sine B, which is 66 degrees. So if we cross multiply, we have that AB times sine 66 degrees equals 220 times sine 87 degrees. So AB equals 220 times sine 87 degrees over sine 66 degrees. So AB equals 220 times sine 87 degrees, which is 0.9986 over sine 66 degrees, which is 0.9135. So AB equals 219.692 over 0.9135. So AB equals 240.495 kilometers. Now to three significant figures, AB is 240 kilometers. Right now to the next question. So question 9 says 2 wires. This should be wires and not wings. That's a typo. So 2 wings support an electricity pole as shown in figure 5.17. If the wires make angles of 58 degrees and 67 degrees with the ground, and AB equals 21 meters, calculate the length of the wires. So this is question 9, and let's calculate the length of the wires. So I'm going to call this point C. Okay, so we need to find this angle here that is opposite the known side. And to find this angle here, we simply take the sum of 58 degrees and 67 degrees from 180 degrees, because the sum of angles in triangle ABC is 180 degrees. And when we get this angle here, we can use the sine rule to solve for the length of the wires, that's AC and BC. So let's do that. Angle C equals 180 degrees minus 58 degrees and 67 degrees. And this is 55 degrees. Okay, so we use the sine rule to find AC and BC. So we say that AC over sine B equals BC over sine A, which is equal to AB over sine C. So let's start with AC. So we say that AC over sine B equals AB over sine C. So we're using AB because we know AB and we know C to be 55 degrees, right? So putting in the values, we say that AC over sine 67 degrees equals AB, which is 21 meters, over sine 55 degrees. So if we cross multiply, we have that AC times sine 55 degrees equals 21 times sine 67 degrees. So we have that AC equals 21 times sine 67 degrees over sine 55 degrees. So AC equals 21 times sine 67 degrees, which is 0.9205 over sine 55 degrees, which is 0.8192. So AC equals 21 times 0.9205, which is 19.331 over 0.8192. So AC equals 23.597 meters. So AC, so three significant figures, is 23.6 meters. Now, let's find the length of the other wire. Alright, so remember BC over sine A equals AB over sine C. So BC over sine 58 degrees equals AB, which is 21, over sine 55 degrees. So when we cross multiply, BC times sine 55 degrees equals 21 times sine 58 degrees. So dividing both sides by sine 55, to isolate BC, we have that BC equals 21 times sine 58 degrees, I beg your pardon, over sine 55 degrees. So BC equals 21 times sine 58 degrees, which is 0.8480 over sine 55 degrees, which is 0.8192. So BC equals 17.808 over 0.8192. So BC equals 21.738 meters. So BC equals 21.7 meters. So three significant figures. Right, so the length of the wires are approximately 23.6 meters and 21.7 meters. Okay, now to the last question. Question 10 says from point A and B on a level ground, the angles of elevation of the top of a building are 25 and 37 degrees respectively. If AB is 57 meters, calculate to the nearest meter the distances of the top of the building from A and B if they are both on the same side of the building. Okay, so let's sketch first and then find the solution. Alright, so this is question 10, and we have that points A and B on level ground, and they're on the same side of a building. Let's say this is the building here. Right? And we're told that the angle of elevation from A is 25 degrees. So it goes this way, 25 degrees. And from B is 37 degrees. Right, so we've been asked to find, and we're also told that AB is 57 meters, right? That's from here to here, 57 meters. Now we've been asked to find the distances of the top of the building from A and B. Alright, so this is C. We call the top of the building C. Okay, this is top of the building here. Alright, so we want to find AC and BC. Find AC. So let's find BC, find AC. Alright, let's solve this then. Okay, and then one thing we should know is that the building, of course, will be perpendicular to the ground, right? So this is a 90-degree angle here, right? So let's see how we can solve this then. So first of all, we need to find this angle here. And we know that this angle here will be 180 degrees minus 37 degrees, because the sum of angles on a straight line is 180 degrees, right? And then once we find this angle here, we can find this angle here, because we know that the sum of angles in a triangle is 180 degrees. Alright, so we know this angle here opposite a known side, so we can then use the sine rule to find the length of AC, which is opposite this angle here, which we will find soon. So now let's do that. So I'm just going to call this O here. We're going to call this point O here. Alright? So first of all, angle ABC equals 180 degrees minus 37 degrees. And the reason is sum of angles on a straight line. So this is 143 degrees. So we write this here as 143 degrees. Now, angle ACB equals 180 degrees minus the sum of 25 degrees and 143 degrees. And the reason is sum of angles in a triangle. So angle ACB equals 12 degrees. So we write 12 degrees here. Alright, so now we can use the sine rule to find the length AC. So we use the sine rule to find AC. So we say that AC over sine of angle ABC is equal to AB over sine of angle ACB. So AC we don't know, but we know angle ABC to be 143 degrees. So this is sine 143 degrees. And it is equal to AB, which is 57 meters, over sine ACB, which is 12 degrees. So if you cross multiply, we have then AC times sine 12 degrees equals 57 times sine 143 degrees. So we're going to divide both sides by sine 12 degrees to isolate AC. So we have that AC equals 57 times sine 143 degrees over sine 12 degrees. So AC equals 57 times sine 143 degrees. That's 0.6018 over sine 12 degrees. And that's 0.2079. So AC equals 34.303 over 0.2079. Now AC equals 164.998 meters. Alright, so to the nearest meter, AC is approximately 165 meters. So now we're to find BC, right? And we know that AC is 164.998 meters. So we're to find BC. So it is better for you not to use the approximations during the calculations. So that's why I stated the length of AC as 164.998 meters, as opposed to using the approximation to the nearest meter of 165 meters. Alright, so let's see how we can find BC. To find BC, we're still using the sine rule. So we say that BC over sine CAB, that's angle CAB, equals AC over sine angle ABC. So we just put in the known values. Sine angle CAB is sine 25 degrees, and AC we know to be 164.998, and sine ABC is sine 143 degrees. So if you cross multiply, we have that BC times sine 143 degrees equals 164.998 times sine 25 degrees. So we have that BC equals 164.998 times sine 25 degrees over sine 143 degrees. So BC equals 164.998 times sine 25, which is 0.4226, over sine 143, which is 0.6018. Now BC equals 69.728 over 0.6018. Now BC equals 115.866 meters. Now to the nearest meter, BC is 116 meters. To the nearest meter. Alright, so that's it. The distance from the top of the building to points A and B are 165 meters and 116 meters approximately. Okay, so that's it for exercise 5C with the sine rule, and we have seen how we can interpret problems involving bearings, sketch them, and then use the sine rule to solve them. We also saw how we can sketch other problems and use the sine rule to solve them. Now we move to solving problems with the cosine rule. Right, so this is the first question on exercise 9E. In this exercise, we'll see how we can apply the cosine rule to solving word problems involving bearings. In some cases, we will apply both the cosine rule and the sine rule to solve the problems. So let's begin with the first question. And the first question says, from a point on the edge of the sea, one ship is 5 kilometers away on a bearing of south 50 degrees east, and another is 2 kilometers away on a bearing south 60 degrees west. How far apart are the ships? Okay, let's see how we can sketch this problem and then solve it. So this is question 1 of exercise 9E. Right, so let's say this is a point on the edge of the sea. So we can draw our 4 cardinal points here. This is north, this is south, this is east, and of course this is west. So we're told that one ship is on a bearing of south 50 degrees east and is 5 kilometers away from the point on the edge of the sea. So let's call this point A, and then the ship that is 5 kilometers away on a bearing of 650 south 50 degrees east. So this is 50 here. Let me write that clearly. 50 degrees. So let's call this ship B. Right? And another is 2 kilometers away on a bearing of south 60 degrees west. All right, so let's say this is 2 kilometers on a bearing south 60 degrees west. That's what we have here. So let's call this C. So let's call this C. It's point C here. So they said, how far are the ships? So this is one ship here at point C and one ship here at point B. So to determine the distance between the ships, that is B and C. So to determine B, determine BC. Okay, so let's represent this in a meter diagram and see how we can solve for BC using this cosine rule. Right, so this is a meter diagram of what I had drawn earlier, and we have our points on the edge of the sea as A, and we have the first ship, which is 5 kilometers from A, at B on a bearing of south 50 degrees east, and we have the second ship, which is 2 kilometers from A on a bearing of south 60 degrees west at point C. So to determine BC, and to find BC. Now we also see that this whole angle from this point to this point is 110 degrees. So we can use the cosine rule to find the length of BC. Now let's see how we can do that. So using the cosine rule, we say that BC squared equals AC squared plus AB squared minus 2 times AC times AB times cos A. So I'm supposed to write this cos A here, but because of the space, I just put it down here. Okay, so this is BC squared equals AC squared, which is 2, that's 2 squared, plus AB, that's 5 squared, minus 2 times 5, that's AC and AB, and times cos A, that's 110 degrees. So BC squared equals 4 plus 25 minus 2 times 2, that's 4, 4 times 5, that's 20, minus 20 cos 110 degrees. So BC squared equals 29 minus 20 times cos 110 degrees, which is minus 0.3420 BC squared, equals 29 minus 20 times minus 0.3420, which is minus 6.84. So BC squared equals 29 plus 6.84, because minus times minus is plus. So we have BC squared equals 35.84. Therefore, BC equals the square root of 35.84, which is equal to 5.987. Now we're supposed to give our answers correct to, that's the distances, correct to 3 significant figures. So BC to 3 significant figures will be 5.99 kilometers. So the solution is that the ships are 5.99 kilometers apart. Okay, now so let's move to the second question. So the second question is, a student walks 50 meters on a bearing of 0.25 degrees and then 200 meters due east. How far is she from her starting point? All right, let's first sketch this. So this is question 2. Exercise 9E. And we're told that a student walks 50 meters on a bearing of 0.25 degrees. So let's say the student starts from this point here. So we draw our 4 cardinal points as usual. See that this is west and east. So she walks on a bearing of 0.25 degrees. Let's say this is 25 degrees here. And she walks for 50 meters. And then when she gets to this point, she walks 200 meters due east. So she gets to this point. Let's say her starting point is A. And then she gets to B. Say this is B here. Call this N1. We can call this S1. We can call this E1. And we can call this W1. So when she gets to B, she walks 200 meters due east. Let me draw this. Looks a little slanty. Yeah. Okay. So she walks 200 meters due east. This is the east direction. I'm going to make it longer. She walks 200 meters. Yep. Due east. All right. How far is she from her starting point? So she walks to this point C. But to find the distance from C to her starting point A, that's this right here. Right? So let's find AC. Okay, so first of all, we can see that this angle 25 degrees is alternate to this here. And this is a 90-degree angle here. So we can say that this whole angle is 90 plus 25, that's 115 degrees. So with this, we can find the length of AC. With this 115 degree angle here, and 50 meter length here, and 200 meter length here, we can use the cosine rule to find the length of AC. Now let's draw this in the meter way and find AC. Alright, so this is question 2 of exercise 9E. Right, and then the student starts from here. We call this point A, the starting point. She walks on a bearing of 0.25 degrees for 50 meters to this point. Let's call this B. So we can call this N1, W1, E1, and S1. That's the 4 cardinal points at point B. And then she walks 200 meters due east of B until she gets to this point. Let's call this C. So we've been asked to find the distance from this point C to her starting point A. Right, so now we can complete these angles here, because this angle here is 25 degrees, so this will be 25 degrees as well, because they are alternate angles. And then we know that this angle here is 90 degrees, right? So the whole of this angle from this point to this point will be 90 degrees plus 25 degrees, and that's 115 degrees. Okay, so we know that this angle here is 115 degrees. Now we can use the cosine rule to solve for AC. Now let's do that. Find AC. So using the cosine rule, so that AC squared equals AB squared plus BC squared minus 2AB, that's 2 times AB times BC times cos B, right? So you just put in all the values in our formula and solve for AC. So we have that AB from the diagram is 50, so this is 50 squared. Then BC from the diagram is 200, so this is 200 squared, minus 2 times AB, which is 50, and BC, which is 200, and B, which is 115, so this is times cos 115 degrees. So I just wrote it down here for want of space. Okay, so it's supposed to be here, but I just put it down here because of the limited space. All right, so this is AC squared equals 2,500 plus 40,000 minus 2 times 50 times 200, that is 20,000 times cos 115 degrees. So AC squared equals 2,500 plus 40,000, that's 42,500 minus 20,000 times cos 15, which is minus 0.4226. So AC squared equals 42,500 500 minus 20,000 times minus 0.4226, which is minus 8452. So this is 42,500 plus 8,452. This is AC squared, of course. So AC squared equals 42,500 plus 8,452, which is 50,952. So AC is the square root of 50,952, and that is 225.725 meters. Okay, now remember, we're to give our distances correct to three significant figures. So AC to three significant figures is 226 meters. So this is the answer. The distance of the student from her starting point is 226 meters. So AC is 226 meters to three significant figures, of course. You have to state this. And then you say that distance of the student from her starting point is 226 meters. So question 3 says, two goalposts are 8 meters apart. A footballer is 34 meters from one post and 38 meters from the other. Within what angle must he kick the ball if he is to score a goal? Okay, so let's catch this information and then solve the question. So we're told that two goalposts are 8 meters apart. So let's say we have one goalpost here, and say we have another goalpost here, and they're 8 meters apart. So we have a footballer at this point, let's say C, is 34 meters from one post, say here, and he is 38 meters from the other. So that's 38 meters. So at what angle must he kick the ball? Within what angle? So within what angle must he kick the ball if he is to score a goal? So that's this angle here. He must kick the ball within this angle here if he is to score a goal to either B or A. Alright, so let's determine what angle C is. This, of course, should be a straight line. Ignore my sketch. This is a straight line, of course. Alright, so let's move to a neater sketch of this and then solve the question. Alright, so this is question 3. And then we're told that the goalposts, let's say A and B, are 8 meters apart. And we're told that the footballer at point C here, 34 meters from one post and 38 meters from the other post. So to find the angle within which the footballer must kick the ball so that he scores a goal. Okay, so we're to find angle C. So using the cosine rule, AB squared equals AC squared plus BC squared minus 2 AC BC times cos C. So we're just going to put in the values of AB, AC, and BC, and then solve the equation to find angle C. So AB is 8, so this is 8 squared equals 34 squared plus 38 squared minus 2 times 34 times 38 times cos C. So 64 equals 34 squared, which is 1156, plus 38 squared, which is 1444. That's 1444 minus 2 times 34 times 38, which is 2584 cos C. So this is 64 minus 1156 minus 1444 equals minus 2584 cos C. So this here is minus 2536 equals minus 2584 cos C. Therefore, cos C equals minus 2536 divided by minus 2584. So cos C equals 0.9814, and C is equal to the arc cos of 0.9814. So C equals 11.068 degrees. Now C approximately to 1 decimal place is 11.1 degrees. Question 4 says CTA is 300 kilometers due east of CTB and CTC is 200 kilometers on a bearing of 123 degrees from city B. How far is it from city C to A? Or how far is it from C to A? Okay, let's move to our Microsoft whiteboard so we can sketch. Alright, so this is question 4, and we're going to sketch the problem. So we're told that CTA is due 300 kilometers due east of CTB. So let's assume that we have CTB at this point here. Have our 4 cardinal points: north, south, west, and east. And we have that A is 300 kilometers due east of B. So you can say this is our point A here, 300 kilometers due east of B. Right, so we have our point A here, 300 kilometers due east of B. And we're told that city C is 200 kilometers on a bearing of 123 degrees from city B. Alright, so we'll draw our bearing of 123 degrees. Remember, we'll move from the North Pole in a clockwise direction and go 123 degrees. So we can say it's somewhere here. Alright, so say this is 123 degrees, and of course this is a straight line. Ignore the crookedness. So this is 200 kilometers to a point C. Alright, so this is C on a bearing of 120 degrees and 200 kilometers from B. So we are to find CA or AC. How far C is from A. So we're to find AC. All right, now we have two known sides, AB and BC. Remember, to use the cosine rule to solve this and find AC, we must have two known sides and an included angle. All right, so we know that this is 123 degrees from the North Pole to this line BC. So it means that this angle here from the South Pole to line BC will be 180 degrees minus 123 degrees, and that is 57 degrees. So if this angle from here to here is 57 degrees, it means that this angle from here to here will be 90 degrees minus 57 degrees, and that is 33 degrees. Okay, so now we have two known sides, AB and BC, 300 kilometers and 200 kilometers respectively, and an included angle of 33 degrees. So we can use this cosine rule to find AC easily. So let's do all of this on the neater sketch and use the cosine rule to find AC. All right, so this is question 4, and we have this here as CTB, and we're told that east of CTB is CTA, and we're told that it is 300 kilometers from B. We're also told that C is 123 degrees on a bearing of 123 degrees from B. So it goes like this. So this angle here, so this is 123 degrees, and it is 200 kilometers from B. So we'll say this is 200 kilometers, and this is point C. All right, so we got this angle to be 57 degrees. That's 180 degrees minus 123 degrees. And then this angle here to be 90 degrees minus 57 degrees, and that is 33 degrees. So we have two known sides and an included angle, so we can now solve for AC. Okay, so we're to find AC. Now remember, the cosine rule is the square of the unknown side is equal to the sum of the squares of the known sides, right, minus 2 times the product of the known sides. I'm just going to write this clearly. And the cosine, this is times, and the cosine of the angle included in between the known sides, which is angle B in this case. All right, so putting in our values, we have BC to be 200 and AB to be 300, that's 300 squared, minus 2 times 200 times 300 times cos 33 degrees. Okay, so AC squared equals 200 squared, which is 40,000, plus 300 squared, which is 90,000, minus 2 times 200 times 300, which is 120,000 cos 33 degrees. So AC squared equals 130,000 minus 120,000 times cos 33 degrees, which is 0.8386. So AC squared equals 130,000 minus 120,000 times 0.8386, which is 100,632. And this gives 29,368. That's AC squared. Therefore, AC equals the square root of 29,368. And that gives 171.371 kilometers. Therefore, AC is approximately 171 kilometers to 3 significant figures. Alright, so the solution to the question is C is 171 kilometers far from A. Right, so this is the solution to the question. So question 5 says a triangular field has two sides 50 meters and 60 meters long. The angle between these sides is 96 degrees. How long is the third side? Okay, so we can easily use the cosine rule to solve this because we have two known sides and an included angle which is known. So we just use the cosine rule to find the length of the third side. Now let's represent this in a diagram first, and then we solve the question. Question 5, and we're told that the triangular field has two sides, 50 meters and 60 meters long, and we have an included angle of 96 degrees. So I'm just going to label this triangle as ABC. And now we can use the cosine rule to find BC. Alright? To find BC. Alright, so BC squared equals AB squared plus AC squared. Remember, the sum of the squares of the known sides minus 2 times the product of the known sides times the cosine of the included angle, which is A in this case. Alright, so BC squared equals 50 squared plus 60 squared minus 2 times 50 times 60 times the cosine of 96 degrees. So BC squared equals 2,500 plus 3,600 minus, this is 6 right here. I'm going to write this clearly. That's 3,600 minus 2 times 50 times 60, and that gives us 6,000 times cosine of 96 degrees. So BC squared equals 6,100 minus 6,000 times the cosine of 96 degrees, which is minus 0.1045. Yep. Okay. Now this is negative. In case you're wondering why this is negative, this is negative because 96 degrees is in the second quadrant. And remember, in the second quadrant, only sine is positive. Okay, so BC squared equals 6,100 minus 6,000 times minus 0.1045. And that's minus 627. So BC squared equals 6,100 plus 627. And this is 6727. So BC is the square root of 6727. Alright, so BC is equal to the square root of 6727, which is 82.018 meters. Now remember, we're given our distances correct to three significant figures, so BC will be 82.0 meters to three significant figures. Now, if you want to learn how to approximate numbers to three significant figures, two significant figures, and so on, I'm going to put a link to a video tutorial that I did on approximations in the description, so you can watch that video to learn this. Alright, so the next question is question 6. Question 6 says, two boats A and B left a port C at the same time on different routes. B traveled on a bearing of 150 degrees and A traveled on the north side of B. When A had traveled 8 kilometers and B had traveled 10 kilometers, the distance between the boats was found to be 12 kilometers. Calculate the bearing of A's route from C. Alright, let's move to our whiteboard and then do our sketch. After the sketch, we'll then go into calculating the bearing of A's route from C. Alright, so we're told that B traveled on a bearing of 150 degrees. That is from the port C. So we measure 150 degrees from the North Pole in a clockwise direction, so somewhere here. So B travels on this trajectory, right? And we're told that A traveled on the north side of B. Now the north side of B could be anywhere in this space, right? And the north side, which is upwards of B. Okay, now it's important not to take it as due north or directly north of B. Okay, because we're just told it's the north side of B. So let's say A somewhere here. So this is A's trajectory. So we're told that when A had traveled 8 kilometers, say this is 8 kilometers, B had traveled 10 kilometers. So we can say this here is 10 kilometers. And we're told that that's B here, okay? We're told that the boats are 12 kilometers apart. That's the distance between the two boats when A had traveled 8 kilometers and B had traveled 10 kilometers. was found to be 12 kilometers. So this distance here between A and B will be 12 kilometers. Now we're to find the bearing of A's route from C. Now remember, this is A's route here, right? So let's find the bearing of A's route from C. The bearing of A's route from C will be this angle from the north pole of C to AC in this clockwise direction here to AC. Alright, so how do we find that? We can simply take away angle C from 150 degrees. Remember, the angle between the north pole of C here and line BC is 150 degrees here. So if we find this angle here between AC and BC and take it away from 150 degrees, we can get this angle here between the north pole at C and line AC. That is angle NCA. That's acute angle NCA. Alright, so that acute angle NCA will be the bearing of A's route from C. Now, since we have three known sides, we can use the cosine rule to find the included angle between AC and BC. So let's move to a neater sketch of this and see how we can do this. And this is our port C, and we have our shape B here, we have our shape A here, and remember, we're told that the bearing of B from C, that's the boat B from C, is 150 degrees. So we take it in a clockwise direction from the north pole of C. So this is 150 degrees. And then A, of course, you know, it's the north side of B. So it's somewhere here in this space, upwards of B, right? And we're told that when A travels 8 kilometers from C, B had traveled 10 kilometers from C, and the distance between A and B was found to be 12 kilometers. So we've been asked to find the bearing of A's routes. This is A's routes right here. So we've been asked to find the bearing of A's route from C. That's this angle measured from the north pole of C to line AC in the clockwise direction. So how do we find it? We can simply take away this angle C here of the triangle from 150 degrees to get acute angle NCA. So you see that the bearing of A's route from C is equal to acute angle NCA, and that is equal to 150 degrees minus angle ACB of the triangle, alright, or angle C. So how do we find angle C? So let me just state that ACB is also equal to angle C of the triangle. So how do we find angle ACB? We can use the cosine rule to find angle C, because we have three known sides. So we can use the cosine rule to find the included angle between AC and BC. So we state the cosine rule like this: AB squared is equal to AC squared plus BC squared minus 2 times AC times BC times the cosine of angle C. So if we put in the values of what we know, we have that AB is 12 squared that AB squared is 12 squared, and AC squared is 8 squared, and BC squared is 10 squared, minus 2 times AC and BC. That's 2 times 8 times 10 times the cosine of angle C, which we do not know. So 144 equals 64 plus 100 minus 160 times the cosine of angle C. So 144 minus 64 minus 100 equals minus 160 cos C. So this here gives minus 20 equal to minus 160 cos C. So if we divide both sides by minus 160 to isolate cos C, we have that cos C equals minus 20 over minus 160. So cos C equals 1. So cos C equals 0.125. Now C equals the arc cos of 0.125, and C equals 82.82 degrees. Alright, so now we know angle C of the triangle, that's angle ACB. So we can easily find the bearing of A's root from C. Remember, the bearing of A's root from C is equal to 150 degrees minus angle C. And this is equal to 150 degrees minus 82.82 degrees. And this is equal to 67.18 degrees. Now we're to give our answer correct to 0.1 degrees. So this is approximately 67.2 degrees to 0.1 degree. Therefore, the bearing of A's roots from C is 67.2 degrees. So this is our answer here. Alright, so question 7 says, leaves her base camp and drives 42 kilometers on a bearing of 032 degrees. She then drives 28 kilometers on a bearing of 154 degrees. How far is she from her base camp, and what is her bearing from it? Alright, let's first draw this on our Microsoft whiteboard and then we solve. Okay, so this is question 7. Okay, so let's say her base camp is at point B here. So we draw our 4 cardinal points: north, south, east, and west. Remember, this is point B here. Alright, so she leaves point B, drives 42 kilometers on a bearing of 032 degrees. So that's from here, say this is 32 degrees. Drives 42 kilometers. it, let's say she drives 42 kilometers to point C. Point C here. Let's call this N1. You can call this E1. You can call this S1. And west of C, west of C, we can call this W1. So from point C, she drives on a bearing of 154 degrees to a distance 28 kilometers from C. Right, so a bearing of 154 degrees goes from the North Pole in a clockwise direction to somewhere here, right? And it's 28 kilometers. So we can say this is 28 kilometers. And this angle here, from this point to this point, is 154 degrees until she gets to this point. So we can call this point A. Right, so how far is she then from her base camp? Remember, the base camp is here at B. So we're asked to find how far she is from her base camp. That's from B to A, right? So we're to find AB, and we're also to find the bearing of her current position from B. That's the base camp. The bearing of her current position from the base camp. That's this angle from the North Pole all the way here. Okay, so let's see how we can do that. Okay, so this is question 7, and remember this is B, where we have the base camp moves on a bearing of 32 degrees, 032 degrees to point C, right? A distance of 42 kilometers from the base camp. And then from C, she moves on a bearing of 154 degrees to A, a distance of 28 kilometers from C. Alright, now to find this included angle, the angle included between BC and AC, we first said that this angle here is 32 degrees because it is alternate to this angle here. And this angle here between the South Pole and AC is 180 degrees minus 154 degrees. And we'll got that to be 26 degrees. So this angle here is 26 degrees. Therefore, this whole angle between BC and AC is 32 degrees plus 26 degrees, and that is 58 degrees. So now we have two known sides, BC and AC, and an included angle 58 degrees, so we can find AB using the cosine rule. So let's find AB first. So find, that's the first part of the question, find her distance from the base camp, which is AB from our diagram. So using the cosine rule, using the cosine rule, AB squared equals BC squared plus AC squared minus 2BC times AC times the cosine of the included angle, which is C in this case. So AB squared equals 42 squared plus 28 squared minus 2 times BC, which is 42, times AC, which is 28, times the cosine of the included angle, which is C, and that's 58 degrees. So I'm going to write this clearly. This is 28, yeah? So AB squared equals 42 squared, which is 1764 plus 784 minus 2 times 42 times 28, which is 2352 times the cosine of 58 degrees, 0.5299. So AB squared equals 1764 plus 784. That's 2548 minus 2352 times 0.5299, and that is 1246.325. Alright, so AB squared equals 1301.675. So AB equals the square root of 1301.675. AB equals 36.079 kilometers. So AB to three significant figures is 36.1 kilometers. Okay, so her distance from the base camp is 36.1 kilometers. Now let's find her bearing from the base camp. So to find her bearing from the base camp, remember we go from the north direction all the way here to find this angle. So that's going to be angle NBA, right? So how do we find it? So angle NBA is equal to angle, okay, so I'm just going to call this N1, S1, W1, and E1, just so there's no confusion, right? So angle NBA equals angle NBC plus angle ABC. So how do we find angle ABC? Alright, so we can do this using the sine rule. Alright, so the second part of the question is find her bearing from the base camp. Alright, so her bearing from the base camp which is B, is equal to angle MBA, which is equal to angle MBC plus angle ABC. And we can also see that angle ABC is angle B in the triangle. Alright, so how do we find angle B? Now we can use the sine rule to find angle B. So AC over sine B equals AB over sine C. So we have that 28 over sine B equals 36.079 over sine 58 degrees. If we cross multiply, we have that 36.079 times sine B equals 28 times sine 58 degrees. So we're going to divide both sides by 36.079 to isolate sine B. So we have that sine B equals 28 times sine 58 degrees divided by 36.079. So sine B equals 28 times sine 58, which is 0.8480 over 36.079, and this is 23.744 divided by 36.079 sine B. So sine B equals 0.6581. So B equals the arcsine of 0.6581. So B equals, and that is 41.16 degrees. NBC plus angle B, and that is 32 degrees plus 41.16 degrees. And that is 73.16 degrees. Okay, so to the nearest 0.1 degree, that is 73.2 degrees. So the nearest 0.1 degree. So we say that her bearing from B, which is the base camp, is 073.2 degrees. So this is the answer to the second part of the question. Right, question 8 says, two ships leave port at the same time. One travels at 5 kilometers per hour on a bearing of 0.46 degrees. The other travels at 9 kilometers per hour on a bearing of 127 degrees. How far apart are the ships after 2 hours? Okay, so the next question here is question 8. And we're told that two ships leave port at the same time. One travels 5 kilometers per hour on a bearing of 0.46 degrees. The other travels 9 kilometers per hour on a bearing of 127 degrees. How far apart are the ships after 2 hours? Okay, so let's say that this is the port here. So it's north of the port, south, west, and east. We're told that the ships leave the port P at the same time, and that one travels 5 kilometers per hour on a bearing of 0.46 degrees. So let's say this is 0.46 degrees here. This is 5 kilometers per hour. Right, and the other travels on a bearing of 127 degrees. That's from here to, say, here. At 9 kilometers per hour. This angle here is, measure it neatly. So this angle here is 127 degrees. Okay, so how far apart are the ships after 2 hours? So I'm going to call this A, point A. I'm going to call this point B. And this is the distance of the ships from each other after 2 hours. So 2 hours means that the ships would have traveled distance of 5 kilometers per hour times 2 hours, which is 10 kilometers for this ship. And this one would have traveled 9 kilometers per hour times 2 hours, which is 18 kilometers. So the distance PB is 18 kilometers and PA or AP is 10 kilometers. So with this information, we can find AB. So this is question 8. At this point here, we have P. This is 46 degrees. Because the first ship goes on a bearing of 0.46 degrees here at a speed of 5 kilometers per hour. So in this direction. And then the second ship goes on a bearing of 127 degrees. That's here at a speed of 9 kilometers per hour. So calculating the angle here, angle P, we first said that this angle here will be 90 minus 46. That gave us 44 degrees. And then this angle here will be 127 degrees minus 90 degrees, and that gave us 37 degrees. So it means that this whole angle here is 44 plus 37. That's 81 degrees. So to find, let's call this point A. let's call this point B. Let's find the distance of the ships, that's A and B, how far apart they are after 2 hours. So let's begin calculations. So the port is at point P. Speed of ship A is 5 kilometers per hour. 5 kilometers per hour. So after 2 hours, ship A covers a distance of 5 kilometers per hour times 2 hours, and that is 10 kilometers. Okay, so it means that AP is 10 kilometers, and then speed of ship B is 9 kilometers per hour. So after 2 hours, ship B covers a distance of 9 kilometers per hour times 2 hours, and that is 18 kilometers. So line BP is 18 kilometers. Now, if you're confused about why we had to multiply the time by the speed, what 5 kilometers per hour means is that for every 1 hour, the distance covered by ship A is 5 kilometers. So if in 1 hour it covers a distance of 5 kilometers, it means that in 2 hours it will cover a distance of 5 times 2. And the same goes here for B. If in 1 hour it covers a distance of 9 kilometers, in 2 hours it will cover a distance of 9 kilometers times 2, which is 18 kilometers. Okay, so now we have our lengths AP and PB, and we also have our angle P. So we can find length AB, which is how far the ships are from each other. So let's find this using the cosine rule. So using the cosine rule, we have that AB squared equals PB squared plus AP squared minus 2 times BP times AP times cos P. So we put in all the values that we have to find AB. So AB squared equals 18 squared, that's BP, plus AP squared, AP is 10, so this is 10 squared, minus 2 times 18, which is BP, times 10, which is AP, times cos 81 degrees, because angle P is 81 degrees. So we have that AB squared equals 324 plus 100 minus 360 cos 81 degrees. And this is 424 minus 360 times 0.15 464, that's cos 41. And this is 424 minus 56.304. And this is equal to 367.696. Of course, this is AB squared. This is AB squared. And this is AB squared. Therefore, AB will be the square root of 367.696. And that is 19.175 kilometers. Therefore, to three significant figures, AB is 19.2 kilometers. So this is the answer. Alright, so question 9 says, a boat sails 4 kilometers on a bearing of 0.38 degrees and then 5 kilometers on a bearing of 0.67 degrees. How far is the boat from its starting point? A. And B is calculate the bearing of the boat from its starting point. Okay, so we draw the diagram of this, we sketch this, and then we solve the question. Okay, so this is question 9. Alright, so let's say the boat starts from this point. We can call this A. So north, south, east, and west. Alright, so the boat sails on a bearing of 38.038 degrees for 4 kilometers. So let's say this is it. 38 degrees for 4 kilometers. So let's say it sails to this point, B. You can call this N1 of B, S1, call this E1, and call this W1. Alright, so from B it's sails on a bearing of 0.67 degrees for 5 kilometers. So let's say it is like this. Say this is 67 degrees for 5 kilometers, right? So points C, let's call this C. So let's find how far the boat is from the starting point. So that's the distance between A and C. So let's connect it with a broken line. Alright. And we're also to find the bearing of the boat from its starting point. So that's the bearing of C from A. Alright, so let's represent this in a metre sketch and solve the question. Okay, so this is question 9. So this is a metre sketch. Remember, we said that the boat starts from point A, goes on a bearing of 38 degrees, goes on a bearing of 38 degrees, and travels 4 kilometers to a point B. Let's call this N1, S1, E1, W1. And from B, it travels on a bearing of 067 degrees to a point C and travels a distance of 5 kilometers. So we're to find the distance of the boat from a starting point A, that's AC, and we're also to find the bearing of the boat from a starting point A, that's the bearing of C from A, right? So let's find AC first, which is the distance of the boat from the starting point. Okay, so first of all, we need to find the included angle between line AB and BC. That is this angle here, right? From AB to BC. So first of all, we find the angle between BC and the South Pole. That's from this point to this point here. Now this angle will be 180 degrees minus 67 degrees, and that is 113 degrees. Okay, so now we know that this angle here is 113 degrees. So we see that this angle here is alternate to this angle here. So we say that this is 38 degrees. Therefore, the included angle from here to here is the sum of 113 degrees and 38 degrees, which is 151 degrees. So we have that our included angle, the angle included between AB and BC, is 151 degrees. All right, now we can use the cosine rule to find AC. So we find AC using the cosine rule. All right, so AC squared equals the sum of the squares of the two known sides minus 2 times the product of the two known sides and the cosine of the included angle, which is B in this case. So putting in the values, we have that AC squared equals AB squared, which is 4 squared, plus BC squared, which is 5 squared, minus 2 times 4 times 5 times cos B, which is 151 degrees. So AC squared equals 16 plus 25 minus 40 times the cosine of 151, which is minus 0.8746. So AC squared equals 16 plus 25, which is 41, minus 40 times minus 0.8746, which is minus 34.984. So AC squared equals 41 plus 34.984, and this is 75.984. This is AC squared. So AC equals the square root of 75.984, and this is 8.71 8.7 kilometers. So AC, so three significant figures, is 8.72 kilometers. So the distance of the boat from the starting point is 8.72 kilometers. Kilometers. Alright, now to find the bearing of the boat from its starting point, let's see how we can solve that. Alright, so the bearing of the boat from its starting point is going to be this angle here from the north pole of A in a clockwise direction to line AC. Alright, and that's going to be angle NAB plus angle BAC. So the second part of the question, which is to find the bearing of C from A, the bearing of C from A is equal to angle NAB from the diagram plus angle BAC. Now remember, angle BAC is also angle A. So we do not know angle A, and we can use the sine rule to find angle A. Find angle A. Alright, so using the sine rule, we say that line BC over sine A equals line AC over sine B. Now we know BC to be 5 kilometers. AC we calculated to be 8.717 kilometers, and angle B we know to be 151 degrees. So how do we find angle A? So simply plug in these values into the equation and then solve for A. Alright, so we say 5 over sine A equals 8.717 over sine 151 degrees. We cross multiply. We have that 8.717 times sine A equals 5 times sine 151 degrees. Right, so we divide both sides by 8.717 to isolate sine A. So we have that sine A equals 5 times sine 151 degrees over 8.717. So sine A equals 5 times 0.4848 divided by 8.717. Alright. So sine A equals 2.424 over 8.717. So sine A equals 0.2781. Alright, so angle A is the arc sine of 0.2781, and angle A is 16.15 degrees. Okay, so remember we stated that the bearing of the boat from the starting point is equal to, from our diagram, angle NAB plus angle A, and angle NAB is 38 degrees plus angle A, which is 16.15 degrees, and that is 38 plus 16.15, which is 54.15 degrees. Okay, therefore the bearing is and of course remember we have to put this to the nearest 0.1 degrees, so this is approximately 54.2 degrees. So we say therefore the bearing of the boat from its here starting point is 054.2 degrees. Okay, so this is the 10th question, and it says a photographer is 350 meters away from a lion and wants to get closer before he takes a photograph. There is a water hole in the direct line between the lion and himself. So he moves at an angle of 8 degrees to this line to a better position 200 meters further on. Calculate his distance from the lion. Alright, so let's represent this information in a sketch. So this is Q10, question 10. So we're told that a photographer is 350 meters away from a lion. So let's say we have our photographer here, and he is 350 meters away from a lion. Let's say we have the lion here. So we have the lion here. Okay. And we're told that there's a water hole in the direct line between the lion and himself. So let's say the water hole is here. Let's call this W. Alright. So he moves at an angle of 8 degrees to this line to a better position 200 meters further on. Let's say this is 8 degrees here. 200 meters further on. 200 meters further on. Let's say it moves to this point, right? Alright, so that's in this direction, right? So it says calculate his distance from the line. So he moves from here to this point here. Let's call this O. Just going to call this O. So his distance from the line will be OL. So we're to find OL. Remember, the distance between the photographer and the line is 350 meters. That's the initial distance, 350 meters. So we have two known sides and an included angle, which is 8 degrees, and we're to find this unknown side, OL. So let's represent this in a neater sketch and then solve for OL. Alright, so this is question 10, and let's say we have the photographer here and the line here, and then in between them we have the water hole. So we're told that he moves at an angle 8 degrees further on from his initial position, a distance of 200 meters to this point. Let's call this O. Find the distance between his better position and the line. That's this new position O and the line. Remember, the distance between the photographer and the line is 350 meters. Alright, so let us find OL. So we can use the cosine rule here because we have two known lines and an included angle. So we can use the cosine rule. So OL squared equals OP squared plus LP squared minus 2OP times LP times cos P. So OL squared equals 200 squared plus 350 squared minus 2 times 200 times 350 times cos 8 degrees. So OL squared equals 200 squared, which is 40,000. Okay, this is squared here, plus 350 squared, one, two, 500, minus 2 times 200 times 350, which is 140,000 times cos 8 degrees. So OL squared equals 40,000 plus 122,500, and that is 162,500 minus 140,000 times cos 8, which is 0.9903. So OL squared equals 162,500 minus 140,000 times 0.9903, which is 138,642. So OL squared equals 238,858. So OL equals the square root of 23,858. So OL equals 154.460 meters. Now to three significant figures, OL equals 154 meters. Alright, so the distance of the photographer from his better position to the lion is 154 meters. And question 11 says, two planks of length 1 meter and 1.2 meter lean against each other as shown in figure 9.21. That's this figure right here. If the angle between the planks is 36 degrees, how far apart are the bottom edges of the planks? That's 1. And 2, what angle does the longer one make with the floor? Alright, so this is question 11, and the first part of the question is to determine how far apart are the edges of the plank from each other. So that's this point and this point here. So I'm going to label this as A, B, C. So what to find BC? And what to determine the angle, the longer one, which is AB, mixed with the ground, that's BC. So to determine this angle here, that's angle B. Alright, so since we have two known lengths of the triangle and an included angle between them, we can use the cosine rule to find the length of BC, and after that we can use the sine rule to find angle B. So first we find BC using the cosine rule. So we know that BC squared equals AB squared plus AC squared minus 2AB times AC times the cosine of the included angle, which is angle A. So BC squared equals AB squared, which is 1.2 squared, plus AC squared, which is 1 squared, minus 2 times 1.2 times 1 times the cosine of angle A, which is 36 degrees. So BC squared equals 1.44 plus 1 minus 2 times 1.2 times 1. That's 2.4 times the cosine of 36 degrees. That's 0.8090. So BC squared equals 2.44 minus 2.4 times 0.8090, and that is 1.942. So BC squared equals 2.44 minus 1.942, which is 0.498. So BC equals the square root of 0.498. Alright, so BC equals 0.7057. So we're to give BC correct to three significant figures. So remember, in approximating to three significant figures, you have to count from the first non-zero digit. Alright, so this is 1, 2, 3. So BC is approximately 0.706 meters. Of course, this is meters here. So this is 2, 3 significant figures. Now let us find angle B using the sine rule. So using the sine rule, we have that AC over sine B equals BC over sine A. So we have that AC is 1 meter. So we put this here, 1 over sine B is equal to BC, which is 0.7057 over sine 36 degrees. So when we cross multiply, we have that 0.7057 times sine B equals 1 times sine 36 degrees. I'm just going to write this clearly as 36 degrees. So we're going to divide both sides by 0.7057 to isolate sine B. So this is equal to 1 times sine 36 degrees over 0.7057. So sine B equals 1 times 0.5878 over 0.7057. So sine B equals 0.5878 over 0.7057. So sine B equals 0.8329. So angle B equals the arc sine of 0.8329. So angle B equals 56.398 degrees. Now remember, we're to give this to the nearest 0.1 degree. So this is 56.4 degrees. So we have the two answers. The answer to the first question as 0.706 meters and the second one as 56.4 degrees. Question 12 says, an aircraft flies due north from Ikeja Airport for 500 kilometers. It then flies on a bearing of 060 degrees for a further distance of 300 kilometers before overflying a road junction. Calculate the distance of the aircraft from Ikeja Airport when it was directly above the road junction That's the first part. And the second part is the bearing of the aircraft from the airport at this instant. That's at the instant where it is directly above the road junction. Right, let's move to our Microsoft whiteboard so we can sketch the information given here and then we solve after sketching. Assuming that we have the Ikeja Airport at this point, let's say we have the airport here, we're going to call it A. So it flies due north for 500 kilometers. So let's draw our 4 cardinal points here at A. So we have north, south, west, and east. So we're told that the aircraft flies 500 kilometers due north from the airport. So we're just going to call this here, this is our airport here. So 500 kilometers, due north. So we'll call this 500 kilometers. Alright, so it flies 500 kilometers to this point here. So we're going to call this point B. We're going to draw our cardinal points here. So we'll call this north of B, we can call it N1. I'll call this E1. I'll call this W1. So from point B, it flies on a bearing of 60 degrees for a further 300 kilometers. So we can call this 60 degrees here for a further 300 kilometers before overflying a road junction. So the road junction will have to be on the same plane level as the airport, so to speak. So let's say the road junction is somewhere here. Alright, so we're told that it flies 300 kilometers before overflying the road junction. So we have the road junction at this point here. Okay. Alright, so calculate the distance of the aircraft from Ikeja Airport when it was directly above the road junction. Alright, so that's this distance. So let's call this point C. And we're told to calculate the distance of C from the airport when it was directly above the road junction. Remember, the road junction is here, right? So we can join A and C with the broken line. Okay, so we're to find AC. We're also told to calculate the bearing of the aircraft from Ikeja Airport at this instant. Now remember, the aircraft is here at C. So the bearing of C from A will be this angle here. That's angle BAC of the triangle. Alright, so let's go to our, so let's do this on a meter sketch and then solve for AC, and then we find the angle BAC of the triangle and get the bearing of the aircraft from the airport when it is directly above the road junction at this point. Well, so this is question 12, and this is a meter sketch of what we had done earlier. So remember, the airport is here at point A. I'm just going to write this airport here. And then we're told that the aircraft flies 500 kilometers due north of the airport. So this is 500 kilometers due north. So this point here, I will call this point B. And from this point B flies in a bearing of 60 degrees. So this is 60 degrees here, and goes for a further distance of 300 kilometers before overflying a road junction. So say the road junction is somewhere here. Say this is the road junction, and I'm just going to draw a broken line to join the just 300 kilometers to join the 300-kilometer line with the road junction. Alright, so at this point C, it is directly above the road junction. So we're told to find the distance of the aircraft from Ikeja Airport when it is directly above the road junction. That is AC from our diagram. This points to this point A. And we're told to find the bearing of the aircraft from the Ikeja Airport at this instant. That's this angle measured from the north pole of A to line AC. Okay, so we can use the cosine rule to find AC, and then after finding AC with the cosine rule, we can use the sine rule to find angle BAC of the triangle. But first of all, we need to find the angle included between lines AB and BC. So how do we find that? First of all, we see that this angle here is 90 minus 60 degrees, and that's 30 degrees. And this angle here is a right angle, right? So the sum of this angle here, 90 and 30 degrees, gives you angle ABC of the triangle. So this is 90 degrees plus 30 degrees. That's 120 degrees. Okay, so now we have the included angle between BC and AB, so we can use the cosine rule to find AC. So AC squared equals the sum of AB squared and BC squared minus 2 times the product of AB and BC and the cosine of the included angle, which is angle B of the triangle. Alright, so AC squared we don't know, so we just put in the values of AB and BC and the included angle to find AC. So AB here is 500, so this is 500 squared, plus BC, which is 300, so this is 300 squared, minus 2 times 500 times 300 times the cosine of B, which is of angle B, which is 120 degrees. That's angle B of the triangle. So AC squared equals 250,000 plus 90,000 minus 2 times 500 times 300, which is 300,000, times the cosine of 120 degrees, which is minus 0.5. So AC squared equals 340,000 minus 150,000. That's 300,000 times minus 0.5. So AC squared equals 340,000 plus 150,000. AC squared equals 340,000 plus 150,000. That's 490,000. So AC equals the square root of 490,000. AC equals 700 kilometers. So the distance of the aircraft when it is directly above the road junction is 700 kilometers. Now to find the bearing of the aircraft when it is directly above the road junction from A. So we need to find angle A of the triangle. Now we can use the sine rule to do this. So now we have calculated AC to be 700 kilometers. We can now use the sine rule to find angle A of the triangle. Find angle A of the triangle. So we simply say that BC over sine A equals AC over sine B. So if we put in the values that we have, the values that we know, we have that BC is 300. We don't know angle A. But we have that AC is 700. And we have that angle B is 120 degrees. So this is sine 120 degrees. So if we cross multiply, we have that 300 times sine 120 degrees equals 700 times sine A. So we're going to divide both sides by 700 to isolate sine A. So we have that sine A equals 300 times sine 120 degrees over 700. So we have that sine A equals 300 times sine 120 degrees, which is 0.8660 over 700. So we have that sine A equals 259.8 over 700. We have that sine A equals 0.3711. So A equals arcsine of 0.3711. And A equals 21.783 degrees. So we're going to approximate this to the nearest 0.1 degree. A is 21.8 degrees. So the nearest 0.1 degree. Alright, so we can say that the bearing of the aircraft from A is 0.21.8 degrees. So this is the answer. So we got the distance of the aircraft when it's directly above the road junction from A, that's from the airport, to be 700 kilometers, and the bearing of the aircraft points directly above the road junction from the airport. We've gotten it to be 021.8 degrees. So that's it for question 12. Alright, so this is question 13, and it says a ship leaves port and travels 21 kilometers on a bearing of 032 degrees, and then 45 kilometers on a bearing of 287 degrees. Calculate its distance from the port. And B, calculates the bearing of the port from the ship. Okay, so as usual, we sketch first, and then after sketching, we find the solution. Alright, so this is question 13. So it says a ship leaves port and travels 21 kilometers on a bearing of 032 degrees. So let's say this is the port here, P. We have our 4 cardinal points: north, this is south, this is west, and east. So he leaves port and travels on a bearing of 032 degrees, like this. This is 32 degrees, and we're told that he travels for 21 kilometers. So he travels and gets to this point. Let's call this O. Let's call this N1, that's north of O. Call this S1, south of O. Call this E1, east of point O, and W1, west of point O. So from point O, we're told that it travels 45 kilometers on a bearing of 287 degrees. So a bearing of 287 degrees would be like this: 287 degrees measured from the north of O, like this, clockwise, until it gets to this point somewhere here, right? So of course this is supposed to be a straight line. Ignore the crookedness. So it travels 45 kilometers. This angle is 287 degrees. Alright? So it travels 45 kilometers, right? Okay, so we're told to find the distance between the ship and the ports. So it travels from this point to this point. Let's call this Q. And we're told to find the distance between the ship and the ports, the distance of the ship from the ports. So that's this distance here. Okay, so now we have two lines, two known distances, or two known lengths of the triangle, 45 kilometers and 21 kilometers. But we need an included angle, that is this angle here. So we'll be able to use the cosine rule to solve the triangle. That's to solve for the distance between the ship at Q and the ports. Okay, so how do we find this angle here? Okay, so we can easily say that this angle from here to here is 32 degrees because it's alternate to this angle here. So it means that this angle here, this small angle here, will be 90 minus 32 degrees. So I'm just going to write it here, 90 degrees minus 32 degrees, and that is 58 degrees. Alright, so we have one part of this whole angle to be 58 degrees. But what about this small angle here? That's this one here. So this one will be 287 degrees minus 270 degrees, and that is 17 degrees. Alright, so this small angle here is 17 degrees. That means this whole angle is 58 degrees plus 17 degrees, and that is 75 degrees. So this whole angle here is 75 degrees. So now we have two known sides and an angle included between them, that's 75 degrees. So with this information, we can solve for the length of QP, right, which is the distance of the ship from the ports. Okay, so let's do this on a neater sketch and then solve the question. So we've been asked to find the distance of the ship from the ports. I've also been asked to calculate the bearing of the ports from the ship. Okay, so let's see how we can do this in a neater sketch. Alright, so this is question 13, and we're told that a ship leaves ports. So we're saying that this point here is the port P, and it goes on a bearing of 32 degrees and travels 21 kilometers. So this is 32 degrees, travels a distance of 21. Let me write this outside. 21 kilometers. So this point, and we'll call this point O. Okay, and then from point O, it travels a distance of 45 kilometers on a bearing of 287 degrees. So it goes from the north, so we call this N1, S1, E1, and W1. So it goes from the north of O in the clockwise direction to this point. That's 287 degrees. Alright. And it travels 45 kilometers to this point, and we'll call this point Q. Okay, so how do we find this included angle? That's the angle between QO and OP, or OQ and OP. Alright, so first of all, we knew that this is 32 degrees here, so it's going to be equal to this angle here, 32 degrees. And then this angle here will be 90 minus 32 degrees. So this angle here will be 58 degrees. So what about this angle here? This angle here will be 287 degrees minus 270 degrees, and that is 17 degrees. Remember, from the north to the west direction is 270 degrees, and this small angle and this whole angle, or the bearing from the north to this line OQ, is 287 degrees, which means that it just goes above the west pole by 287 minus 270 degrees, I beg your pardon, and that's 17 degrees. Right, so this angle here is 17 degrees. So it means that this whole angle from OP here, between OP and OQ, is 58 plus 17 degrees, and that is 75 degrees. So that's how we got 75 degrees here. Okay, so how do we solve for QP now? We can use the cosine rule because we have two known sides and an included angle. Alright, so let's use the cosine rule to solve for QP. So let's find the distance of the ship from the ports, okay, which is PQ. It says PQ from our diagram. So using the cosine rule, PQ squared equals OQ squared plus OP squared plus minus 2 times OQ times OP times the cosine of angle O, right? So this is angle O and not 0, all right? Angle O as shown in the diagram, which is 75 degrees, all right? So this is PQ squared. We just put in the values. OQ is 45 kilometers, that's 45 squared, plus OP, which is 21, so it's 21 squared minus 2 times 45 times 21 times the cosine of angle O, which is 75 degrees. So PQ squared equals 45 squared, which is 2025 plus 21 squared, which is 441 minus 2 times 45 times 21, which is 1890 times the cosine of 75 degrees. That's 0.258. Okay, so PQ squared equals 2466 minus 489.132 and this is PQ squared equals 1976.868. This is 6 here. Let me write this clearly. Alright, so this is 6. Yeah. Okay, so PQ equals the square root of 1976.868, and that is 44.462 kilometers. So to three significant figures, it is 44.5 kilometers. PQ, the distance of the ship from the port is 44.462 kilometers. So we can just write that down. So we can just write that down here. 44.462 kilometers. So we have to find the bearing of the port from the ship. So that bearing will go from the north pole of the ship all the way to this line, that's line PQ, between the ship and the port, right? Now, this angle, which is N2QP, will be 90 degrees plus this angle here, which is 17 degrees, as it is alternate to this angle here, plus this angle here, that's angle Q of the triangle. Now we don't know what this angle Q of the triangle is, so we can use our sine rule to find it. So now let's find angle Q of the triangle. Alright, so we use the sine rule to find angle Q. Alright, so we say that OP over sine Q equals PQ over sine O, that's sine of the angle O, right? And we know that OP is 21, so we're just putting all the values. We don't know sine Q, so we write this here. We know that PQ is 44.462 over the sine of angle O, which is 75 degrees. So if we cross multiply, we have that 44.462 times sine Q equals 21 times sine 75 degrees. So sine Q equals 21 times sine 75 degrees over 44.462. So sine Q equals 21 times sine 75, and that is 0.9659 over 44.462. So sine Q equals 20.284 over 44.462. So sine Q equals 0.4562. So Q equals arcsine 0.4562, and Q equals 27.142 degrees. Alright, so to find the bearing of the port from the ship, we know that this bearing is equal to angle N2 QP, which is equal to 90 degrees plus 17 degrees plus 27.142 degrees as shown in our diagram, and this is 134.4142 degrees. Now, we've been told to approximate to the nearest 0.1 degrees, so this is approximately 134.1 degrees. So it means that the bearing of the ports from the ship is 134.1 degrees. So this is the answer. Right, so question 14 says, an aircraft flies round a triangular course The first leg is 200 kilometers on a bearing of 115 degrees, and the second leg is 150 kilometers on a bearing of 230 degrees. How long is the third leg of the course, and what bearing must the aircraft fly? So this is question 14. Let's say the aircraft starts at this point A. This is north, south, east, and west. So we're told that it flies on a bearing of 115 degrees. So it goes like this to this point somewhere here. So this is 115 degrees. And it flies for a distance of 200 kilometers to this point. Let's call it B. So from B, it begins the second leg. This is S1, E1, and W1. So from B, it does the second leg on a bearing of 230 degrees for 150 kilometers. So that's going to be from here all the way to somewhere here. So let's say this is the distance 150 kilometers, and this is 230 degrees. Alright, so how long is the third leg of the course? So let's say it flies to this point here, call this C. So we can complete this like this and say this is triangle ABC. We can connect point A to point C to make it triangle ABC. Alright, and we've been asked to find how long the third leg will be. Remember, it's a triangular course, so it has to travel from A to B, B to C, and then from C back to A, so that it completes a triangle, right? Okay, so we've been asked to find how long the third leg will be, which is AC, and also on what bearing must the aircraft fly. Okay, so we can draw our four cardinal points here at C. Okay, so we're to find the bearing that the plane must fly from C to get to A. So that's this angle from this North Pole all the way here. Okay, so let's see how we can solve this. So let's draw a neater sketch of this and then get to work. Sketch, and we have this as question 14. So remember, the aircraft starts from this point here, and we'll call it A. So it goes in a triangular course. Now the first leg is 200 kilometers on a bearing of 115 degrees. So let's say this is a 115 degree angle, and it flies 200 kilometers to this point B, and from point B it does a third leg and travels 150 kilometers to on a bearing of 230 degrees. So that's from the north of B, so we can call this N1, E1, S1, W1. So it goes like this until it gets to this point here. So this angle is 230 degrees. So it gets to point C, and then it flies back to A so that it completes the triangular course. Okay, so we've been asked to find the distance of the third leg, which is AC, and also to find the bearing the plane must fly from C to get to A. So that's the bearing of A from C. So that's from the north of C. So we can call this N2, we can call this E2, S2, and W2, just to distinguish it from the other cardinal points at A, B, and C. Alright, so it goes from the north direction in the clockwise direction to line AC, right? So this is the bearing of A from C. That's reflex angle N2CA. Okay, so let's see how we can solve this. First of all, we need to get our included angle. Right, this is 115. Okay, so how do we get our included angle? Okay, first of all, we know that this is 230 degrees. So it means that this angle here will be 270 degrees minus 230 degrees. And that is 40 degrees. So this small angle here is 40 degrees. What about this angle here? How do we get it? So we know that this angle from this point to this point is 115 degrees. And we know that this is a 90 degree angle here. So it means that this small angle here will be 115 degrees minus 90 degrees. And that is 25 degrees. Okay, so we know that this angle here is 25 degrees. So this angle here is alternate to this angle here, so this will be 25 degrees as well. So it means that the whole of this angle here will be 40 plus 25 degrees. And that is 65 degrees. Alright, so we have our included angle, 65 degrees. Alright, so we have two sides, two known sides, 150 kilometers and 200 kilometers, and our included angle, 65 degrees. Alright, so how do we solve for AC? Okay, we can use the cosine rule to solve for AC. So let's do that. So use the cosine rule to find AC. So AC squared equals AB squared plus BC squared minus 2AB times BC times the cosine of angle B. Alright, so we're going to put in values. AC squared equals 200 squared plus 150 squared minus 2 times 200 times 115 times cosine of angle B, which is 65 degrees. So AC squared equals 200 squared, which is 40,000. Plus 150 squared, which is 22,500. Minus 2 times 200 times 150, which is 60,000. Times cos 65 degrees, which is 0.4226. 0.4226. So AC squared equals 40,000 plus 22,500. That is 62,500 minus 60,000 times 0.4226. And that is 25,356. So AC squared equals 37,144. So AC equals the square root of 37,144. And that is equal to 192.728 kilometers. Now remember, we're to give our answers correct to three significant figures. So this is approximately 193 kilometers to three significant figures. Okay, so we use the sine rule to find angle C. Alright, so AB over sine C equals AC over sine B. You know that AB is 200 kilometers over sine C. AC is 192.728, and then B is 65 degrees, so this is sine 65 degrees. So if we cross multiply, we have that 192.728 times sine C equals 200 times sine 65 degrees. Then sine C equals 200 times sine 65 degrees over 192.728. So sine C equals 200 times sine 65 degrees, and that is 0.9063 over 192.728. So sine C equals 181.26 over 192.728. So sine C equals 0.9405. So C equals back sine 0.9405, which is equal to 70.136 degrees. Alright, so now we know angle C. So it means that acute angle N2 CA equals 70.136 degrees minus 50 degrees, which is 20.136 degrees. All right. Therefore, okay, so acute angle N2CA equals 70.136 degrees minus 15 degrees, and that is 20.136 degrees. So reflex angle N2CA equals 360 degrees minus 20.136 degrees, and that is 339.864 degrees. Okay, so you see that the bearing we're finding that the bearing the aircraft must fly to complete the third course is equal to reflex angle N2CA from our diagram, which is equal to 339.864 degrees. Now remember, we're to give our answer to the nearest 0.1 degree, and that will be 339.9 degrees. So this is the bearing. So this is the last question we'll be solving, and it says villages A, B, C, D are such that B is 4 kilometers due east of A, and C is 3 kilometers due south of B, and D is 4 kilometers south 40 degrees west from C. Calculate the distance and bearing of A from D. Okay, so let's move to our whiteboard to see how we can solve this. Okay, so this is question 15. So we're told that villages A, B, C, D are such that B is 4 kilometers due east of A. So if we have point A here, we have four cardinal points: north, south, west, east. We're told that B is 4 kilometers due east of A. So let's say this is 4 kilometers, and you have B here. So we're going to call this N1. This is E1. This is S1, because this is west of B, W1. Okay, and we're told that C is 3 kilometers due south of B. So this is due south of B, and we have C, 3 kilometers. Of course, this is N2, which is north of C. Beg your pardon, that's north of C. South of C, S2, E2, and W2. And we're told that D is 4 kilometers south 50 degrees west from C. D is south 50 degrees west from C. D is south 50 degrees west from C. So we have that here will be 50 degrees. And it's a distance of 4 kilometers from C. So this is 4 kilometers, and this is point D here. So let's calculate the bearing of A from D. I have 4 cardinal points here. This is N3. Okay, Okay, so this is the distance of A from D, and the bearing of A from D is this angle here from the north all the way here. Okay, so that's reflex angle NDA. Alright, so let's redo this in a neater way and then put in all the information. Okay, so this is a neater sketch, and of course we're told that B is such that it is 4 kilometers due east of A. So if this is our point A here, this is east of A, then this will be B, 4 kilometers due east of A. So we can call this N1, E1, S1, W1. Now we're told C is 3 kilometers due south of B. So if this is C here, this will be 3 kilometers due south of B. And D is 4 kilometers southwest, south 50 degrees west from C. So if this is D here, this is 50 degrees, south 50 degrees west, and of course this is 4 kilometers. So we're told to find the bearing of course, we can call this N2, E2, S2, W2, N3, E3, S3, and W3. So we're told to find the bearing of A from D, and that will be reflex angle N3DA. That's from this north pole to this point here. And we're also to find the distance from A to D, that's line AD. Okay, so now you see that I have joined points A and C with a broken line, and I've joined points A and D with a broken line. Okay, so let's see how we can find AC first. Then we can find this angle here. Then we can find this angle here and this angle here to give us this whole angle here. So with this whole angle here and this side, AC, we can use the cosine rule to find line AD. Okay, so let's find line AC first. So we can use the Pythagorean theorem to find line AC because angle ABC is right angle, so it means that triangle ABC is a right angle triangle. So we use Pythagoras' theorem to find AC. So we have that AC squared equals AB squared plus BC squared. So AC squared equals 4 squared plus 3 squared. That is 16 plus 9. So AC squared. So AC squared equals 25. So AC equals the square root of 25, and AC equals 5. That's 5 kilometers. So we have that AC is 5 kilometers here. So how do we find this angle here? That's NCA. That's N2CA, this angle right here. So we know that This angle here is that the sine of this angle here is opposite, which is AB, over the hypotenuse, which is AC. So let's write that down. Sine angle N2CA equals line AB over line AC, which of course is opposite over the hypotenuse. So sine N2 CA, the sine of angle N2 CA equals AB, which is 4 over 5, which is 0.8. So angle N2CA is the arcsine of 0.8. That is 53.13 degrees. Okay, so we write this in our diagram. So this angle here is 53.13 degrees. So if this angle here is 53.13 degrees, this angle from here to here will be 90 minus 53.13 degrees, and that is 36.87 degrees. And if this angle from here to here is 50 degrees, here will be 40 degrees. That's 90 minus 50 degrees. So 36.87 degrees plus 40 degrees will give you this total angle here. 36.87 degrees plus 40 degrees gives this total angle here from here to here. And that is 76.87 degrees. Okay. So now we know this angle, we know this side to be 5 kilometers. So we can easily find AD using the cosine rule now. Alright, so let's use the cosine rule to find AD using this length 4 kilometers, this length 5 kilometers, and this angle 76.87 degrees. Alright, so we use the cosine rule to find line AD. So AD squared equals AC squared plus CD squared minus 2 times AC times CD times cos C. So AD squared equals 5 squared plus CD 4 squared minus 2 times AC, which is 5, times CD, which is 4. That's cos 76.87 degrees. Alright, so AD squared equals 25 plus 16 minus 40, that's 2 times 5, 10, 10 times 4, 40 times cos 76.87 degrees. So AD squared equals 41 minus 40 times cos 76.87 degrees, which is 0.2272. So AD squared equals 41 minus 9.088. So AD squared equals 41.912. AD equals 31.912, that's 5.649 kilometers. So AD, correct to three significant figures, is equal to 5.65 kilometers to three significant figures. Okay, so now we found the length of AD. And that's 5.649 kilometers. So how do we find the bearing of A from D, which is reflex angle N3DA? So first of all, we need to know this angle here. And then we take 360 degrees, and then we take this angle here from here to here, away from 360 degrees, and that will give us reflex angle N3DA. But first of all, let's find this angle here from the North Pole to line CD. So we see that this angle here is 50 degrees and it's alternate to this side. So this angle here will be 50 degrees. So if we know this whole angle here from here to here, we can take 50 degrees away from this angle, and that will give us this angle here. So we can find this angle here using the sine rule. Okay, so let's find that first. So using the sine rule, AC over sine D equals AD over sine C. So we know that AC is 5 kilometers. We don't know sine D. We don't know angle D. We know that AD is 5.649 kilometers as we calculated here. And we know that angle C is 76.87 degrees as we have calculated. So angle C, that's 76.87 degrees. So sine C is sine 76.87 degrees. So if we cross multiply, we have that 5.649 times sine D equals 5 times sine 76.87 degrees. So we have that sine D equals 5 times sine 76.87 degrees over 5.649. So sine D equals 5 times 0.9739 over 5.649. So sine D equals 4.8695 over 5.649. So sine D equals 0.8620, and angle D equals arcsine 0.8620. So angle D equals 59.54 degrees. Okay, so we have our angle D to be 59.54 degrees. So we have that this angle here from this point to this point is 59.54 degrees. So it means that this small angle here will be 59.54 degrees minus 50 degrees. So we have that this angle here will be 9.54 degrees. So line here. So bearing of A from D is north 9.54 degrees west, or three-figure bearing is 360 degrees minus 9.54 degrees. And this is 350.46 degrees. Right, so to one decimal place, bearing of A from D is north 9.5 degrees west, or 350.5 degrees. So this is the acute angle bearing, and this is the three-figure bearing. So that's the solution to the question. We got the length of AD to be 5.65 kilometers, and the bearing of A from D to be north 9.5 degrees west, or 350.5 degrees in the three-figure notation. So that's going to do it for our video on bearings and distances using the sine and cosine rule. If you have any suggestions, please leave them in the comments, and if you found this video valuable, please like and subscribe. Thank you for watching.